Ladies and gentlemen, dear friends, good morning. I wish to welcome you all here in Tallinn to the international conference Arctic and Antarctic Science Cooperation in our changing world. I hope that over the next 2 days we will study some of the most pressing challenges and opportunities for our time. Experts from around the world reflects the powerful spirit of collaboration essential to polar research and reminds us that polar region changes are far-reaching, affecting not only these remote areas, but all our world. Our conference this year have a special importance as we also celebrate the 14th anniversary of the Estonian Polar Club. For decades, the club has been a center for knowledge and the bridge between Estonian international research communities, between Estonian and international research communities. We celebrate this anniversary with pride, and we are honoring the generation of scientists, explorers, and all enthusiastic people who have made this research in Estonia possible. But and the same way, when I shall say deep thanks to all these people, I shall mention also those who will carry this legacy forward, and I think it's extra important. Our world is changing rapidly, and I don't mean here not only the climate changes, but wars, global stability. We all know that we have huge problems. I can say that everywhere. But okay, if we are talking only about climate changes and about medium temperatures, it's nowhere more evident than in the polar regions. Melting ice, also melting permafrost. These changes are in very tender ecosystem, very power impact, not only for the life in these polar regions, but the impact, as we know, is global. Our discussions here will address also this impact on the communities and countries that depend on polar stability. In today's interconnected world, science cooperation is our greatest tool to understanding and addressing these challenges. This conference brings together experts from Norway, Finland, the United Kingdom, Chile, the United States, and of course from Estonia. We are going to share insights from various fields: marine biology, glaciology, anthropology, environment diplomacy, and many more. I hope that each session promises to enlarge our understanding and, importantly, to inspire new avenues of collaboration. I also would like to highlight the role of small countries like Estonia. Estonia is, of course, proud to contribute along larger research nations to our shared goals. Let this conference serve as a reminder that polar research is about our collective responsibility for preserve and understand our planet's future. The work we do here will impact not only polar regions. We are taking about future for all. It's maybe something a little bit more, but I think it's really so. Finally, I would like to open this conference, the International Polar Conference 2024, and may our discussions be fruitful. I hope we talk about the collaboration not only in coming days, but also in the future. Thank you once more and welcome to Tallinn. And thank you. And now I am happy to introduce Minna-Liina Lind, Undersecretary for Global Affairs, Ministry of Foreign Affairs of Estonia. Thank you once more. Yeah.
Aitäh. Good morning. I'm really pleased to be here this morning celebrating 40 years of Estonian Polar Club with this exceptional international conference. And dear all organizers, dear ambassadors, dear ladies and gentlemen, all the scientific community. Just over a year ago, I held a speech at our Academy of Sciences, where I mentioned that Estonia is one of the northernmost non-Arctic countries. This closeness can be felt as climate change in the Arctic is progressing. Its effects also manifest in our region. Changes in the coastal erosion and ice regime of the Baltic Sea, in the composition and circulation of the atmosphere, as well as in the biodiversity of our region, are closely intertwined with changes in the Arctic. Understanding those challenges and responding to them requires cooperation. Therefore, Estonia considers itself a dedicated partner and friend for Arctic countries. Our focus has been and remains on our contribution to the sustainable development of the Arctic. Our polar research traditions have a very long history, and our scientists have long-standing commitments to polar research on several topics. The field of expertise is really diverse, from Arctic atmosphere and biosphere research and ice core studies to social sciences and research collaboration with indigenous peoples. On the technical side, we also have notable capabilities in developing underwater autonomous vehicles to study Arctic marine environments. More widely, Estonia is known as one of the most integrated, forward-looking and digitalized countries in the world. Our data-oriented approach could come handy for solving also the challenges facing the Arctic. All this gives our scientists a stake in spearheading those global efforts. As a party to the Antarctic Treaty, Estonia is committed to preserving and strengthening international norms in the Antarctic region. Estonia has research history on the continent. Contemporary Estonian scientists have cooperated with other countries for research purposes in Antarctica, sometimes using their facilities. Estonia is committed to the protection of the rules-based international order everywhere, including in Antarctica, which is affected by global tensions. Ladies and gentlemen, I would like to thank the Estonian Polar Club once again, whose 40th anniversary we have gathered here to celebrate. And your mission is to promote knowledge about the polar regions, and your dedication to doing this through human connections is truly admirable. It is also essential in raising the next generation who values the scientific approach to care for and learn about our shared planet. 40 years is also a significant number. 40 years ago, it was a completely different time in Estonia, and the possibilities for civic organization were far more restricted, even impossible sometimes, than they are today. The fact that you managed to establish yourselves already back then and continue until today manifests the grassroots level interest and care for polar issues in our society. Meanwhile, not only has our society become free, but our attitude towards environmental protection has also changed. Estonia has considerably stepped up its climate action in recent years. This paradigm shift demands a fundamental transformation of society, economy, and also the mindset. We place climate policy at the center by implementing the Green Transition Action Plan. We are focusing on capacity building and sharing of experiences in the digital and green transition in international cooperation. We hope to build new partnerships with other ambitious countries and see this paradigm shift resonate more widely also in the world. In the Arctic context, I'm happy to announce that since the beginning of this year, the Estonian Ministry of Foreign Affairs has its very own Arctic Action Plan. Developments in the Arctic directly impact us, and we aim to contribute actively. A comprehensive action plan consolidates our aims and efforts. The Baltic Sea remains the focus of our regional cooperation. Our overreaching aim is to contribute to the sustainable development of the Arctic and the understanding of the connections between environmental changes in the Baltic Sea and the Arctic region. We aim to achieve this through scientific cooperation and also in the field of regional cooperation, environmental protection, and climate diplomacy. We want to maintain scientific and civil society links with Arctic indigenous peoples and strengthen those connections in areas where we have expertise or capabilities to contribute. In terms of security, we want the Arctic to remain a conflict and tension-free region. To achieve this, it is important for the allies to ensure situational awareness of security developments in the Arctic and the ability to deal with threats from all directions, including the Arctic. Ladies and gentlemen, the level of freedom in a society can be judged based on how it engages its most vulnerable members. In the wider world, we might assess the level of freedom based on how smaller nations are treated. With its unjustified and brutal war against Ukraine, Russia has alienated itself from the principles of peaceful international cooperation. Today, Russia has an overwhelming military presence in the Arctic, and its interest to enhance its military capabilities there have grown. For this reason alone, we need to pay attention and stay vigilant. We are also witnessing utter disregard towards the environment by aggressor states. The current Russian regime also does not seem to prioritize the protection of Arctic environment. We rather see Russia overexploiting Arctic territories to advance its economic interest at the expense of the environment and indigenous peoples. We see Russia staking everything on fossil fuels, even as it is consumed by ever larger forest fires and the large-scale melting of permafrost. Not surprisingly, in the Arctic, the consequences of Russia's aggression have hit the hardest scientists, activists, and indigenous peoples whose work depends on cross-border access. The NGOs that so need international cooperation are being harassed and threatened with the label of foreign agent, or even worse. Environmental activists are frequently sent to jail. But there is another global actor, China, whose activities must also be monitored. While Chinese footprint both in the Arctic and Antarctic is so far mainly scientific, commercial, and economic, there are potential risks in their actions. We are also monitoring the increasing Sino-Russian cooperation in the Russian Arctic. For example, non-ice class vessels are increasingly used by the two in polar regions, creating additional environmental risks. Although thus far China has played by the rules, they have articulated their much wider ambitions a long time ago. We believe that it is in everyone's interest to maintain the Arctic as a low-tension area where international law is upheld and peaceful scientific interests prevail. We believe that the current geopolitical context calls for a consolidation of like-minded countries with renewed focus on preserving a habitable planet. In case of Arctic, the relevant governance structures such as the Arctic Council are there, as necessary and relevant as ever. The question is how to make most of them in a situation where one Arctic state does not play by the rules nor the spirit of such cooperation, and poses a conventional as well as a hybrid threat. From our perspective, the Arctic Council should continue its policy of openness for new partners, new observers, and based on merit. Ladies and gentlemen, we firmly believe that all indigenous communities should have a strong voice in discussing the future of the Arctic, and we wish to represent that voice. For us, this region is not about economic gain or geopolitics. It is in our heart, and I guess it is safe to say that the Arctic is also in our DNA. Finno-Ugric roots unite Estonia with the indigenous peoples of the Siberian Arctic. For decades, Estonian ethnographers, linguists, and folklorists have studied the indigenous people of the Russian Arctic. The University of Tartu has also been pioneering the field of genetic studies and personal medicine. The largest genetic database of Siberian peoples is stored in Estonia. Estonia has been continuously supporting the indigenous peoples of the world through the UN structures, and we are a strong supporter of the World Congress of the Finno-Ugric peoples. Since 1999, we also have a state program to support the languages and cultures of the Finno-Ugric and Samoyed indigenous peoples. Honored guests, in closing, I believe that this conference will demonstrate how closely connected not only the Baltic Sea and the Arctic are, but both polar regions with each other and with the changes on the whole planet. I do wish you a very, very fruitful discussion for the next 2 days, and I do also hope that from the Ministry of Foreign Affairs side that we can be a good cooperation partner for the Estonian Polar Club also in the future to spread this knowledge and build those crucial connections that will actually help us understand and respond to the climate crisis, as was also talked about before. Thank you very much. Have a good day, and I will see you later. Thanks.
Wow. From this perspective, the audience looks magnificent. Don't you agree? Dear friends of Polar, my name is Martin, and I would like to say a couple of words before we start with our first session. And our first session is about research in Svalbard. This morning, we will embark on an intellectual journey through the icy landscapes of Svalbard, exploring the cutting-edge research that is shaping our understanding of this fragile and rapidly changing environment. Svalbard, as you may already know, with its harsh climate and pristine ecosystems and extraordinary biodiversity, offers to us, to the world, to the global community, unparalleled natural laboratory for researchers, from its tundra ecosystems and glacial dynamics to its seabed sediments and coastal processes. Svalbard presents challenges that demand innovation, of course, collaboration, we can't do anything without that, and interdisciplinary approach, of course. Our speakers today in these sessions represent an impressive array of expertise, from plant ecology and glacial studies to advanced measurements technologies and the long-term community research and so on and so on. Their work highlights not only the resilience of life in extreme environments, but also the pressing need to understand the impacts of climate change in the Arctic and a region warming at more than twice the global average. But first of all, we will begin today's session with Professor Lauri Laanisto. whose work dwells into the intraspecific variability of functional traits in Arctic plants, uncovering their remarkable adaptability. Then after that, we will turn to Dr. Peter Maciek, whose decade-long research on the Arctic tundra will provide valuable insights into how these communities are responding to our rapidly changing climate. Later, of course, Professor Maarja Kruusmaa will introduce to us the fascinating world of robotics and innovative measurement techniques for studying glacial meltwaters and coastal dynamics and so on. Me, myself, I will explore a little bit about the significance of Arctic seafloor sediments and their role in, for example, in methane dynamics and nutrient dynamics and also in other aspects. Finally, we will hear from Professor Rico Noormets straight from Svalbard. His extensive experiences in both research and also in teaching in Svalbard offers a very comprehensive perspective of the region's past, present of course, and gives a glimpse to the future. I believe each of these talks builds a rich tapestry of what research in Svalbard looks like. Research in Svalbard, of course, it's challenging, but at the same time it's collaborative, deeply meaningful for our global understanding of environmental changes. So, dear polar friends, thank you for joining us today, and let's dive into the wonders of Arctic science, starting with our first presenter, Professor Lauri Laanisto. Please, enjoy.
Okay. Hello, I'm Lauri, mainly from Tartu, but sometimes I end up in Svalbard as well, more or less over the last 6-7 years. I've been going there every summer, and we started out staying in this station, that's the Czech station, but now recently we have moved to the Polish station. This is a little bay called Petunia Bukta in the more or less center of Svalbard, and the town Pyramiden is about 5 kilometers from here to that side. So as most of the people in the audience probably are not plant ecologists, I can see only maybe 1.5, and I'm usually doing presentation in ecological or plant-related conferences. I'm not going to go too much into the science this time, and I'm just trying to convince you maybe why it makes also sense to study plants in the Arctics and Antarctics as well. So because usually when I go to either of those stations or in some place in Longyearbyen where I see other scientists, they are all studying, how the rivers are forming or how the glaciers are melting, and some specific, usually marine animals that live only on polar regions. So the kind of essence of doing science in the Arctics is that people study their things that you cannot study anywhere else in the world. So nobody really notices or has any interest in studying plants. And the main question I always get to ask is, why do you go this far up north to study plants? Because plants are everywhere in Estonia, and wherever you go there are plants. Of course there are plants. everywhere, but and the plants in Svalbard are not really very big and not very fancy, and they are not very diverse. There is only about 160 species of plants in the Svalbard archipelago, in comparison with about 2,000 plant species in Estonia. But the thing is that the reason I want to study plants in the polar regions is how is related to the complexity of ecosystems. So if we talk about terrestrial ecosystems, then usually they have quite a lot of species. For example, this rainforest on the left, there is a lot of biomass. Every species tends to have a lot of interactions, and there is this theory that terrestrial ecosystems are too complicated for humans to even try to understand it. So, for example, there is this one working model in community ecology where the central part is called the black box, because we just really don't know what's going on in there. So from that perspective, my kind of idea is to study maybe plants in a place where they are small, they are scarce, and they don't have too many interactions. So maybe it would be possible to understand something what goes on in plant ecosystems in terrestrial landscape, because the general idea is, or that we assume that the principles of how ecosystems work are universal, but it's just completely different complexity how to study them in the warmer and the colder areas. Okay, so today I thought I just mentioned one tiny aspect of all the things that I tried to study in Svalbard is the interspecific trait variability, which basically is the variability within one species. I usually show this picture as an example of how big can it be. Okay, this is obviously not natural selection that has taken us so far, but something like that happens in nature as well. For example, here is a nice example from the tropics, from an island in Panama Canal, where there is a huge experiment where every year hundreds of people are measuring every tree in one 50 by 50 hectare plot or something like that. And on the x-axis is the time from the beginning of the experiment in the 80s, and it's more or less 20 years of measurements. So every line is one individual of one species, Jacaranda, what's that, copia, and on the y-axis is the diameter of this tree individual. So it started, all of those individuals started as like a finger sized tiny trees, and on the course of 20 years they have grown completely different ways. Some of them have become relatively big trees, some of them have remained the same. And the thing is that if you put all the other tree species from this island into the same model that started out small, then they all fit within this one species variability. So there is a huge variability in nature, in size, in different traits that we think are important for the fitness of the species and so on. And we really don't know much about it. But there is a lot of studies that have tried to understand the patterns of interspecific trait variability. I just showed two of them with plants. Here is one that was made in the French Alps, in the Alpine Valley. Each column here is one species, And here is the variability of a trait. This is plant height, this is leaf nitrogen content, leaf dry matter content. It's just some functional traits of plants that we usually study. And we see that a lot of variability is the dark one, which is between populations of the same species growing in slightly different places. So there are subpopulation variability and within individuals. And you can see that it's a mess. And usually the conclusion is that, okay, there is quite a lot of variability, but why is it there? We don't know. On a global scale, some friends of mine made a meta-analysis taking into the same data set all those studies that were done on the interspecific trait variability on plants. And what they found was more or less the same kind of picture. Here, instead of species, each block spot is one variable, one functional variable, and you can see that they are varying in a very different rate within populations and between populations. And basically what they concluded is that there is about 1/4 to 1/3 of variability that we find in plant communities is within species, but we don't know why is it there. So this is one of the things I'm thinking why I should try to study it in a more simpler system. And there is also this kind of thing that when usually ecologists, especially plant ecologists, do science, they like to do the science next to where the university is, as close as possible. Because going to a field, you always forget something, and it's easy to go back if the distance is like 10 kilometers, but if it's in Svalbard, it's very bad if you forget something crucial. So the thing is that people study nature close to their home, assuming that the same principles apply everywhere. But in some aspects of this, it feels like this old, I don't know, is it fairy tale, that some blind old men are touching an elephant. It's, I think, this Persian fairy tale that some of them are touching the tail and some are touching the trunk, and they are concluding that it's a completely different animal because it's so different from different parts of it. And for example, if we think about the Scots pine, Pinus sylvestris, almost one of the most common species in Estonia. This is the blue is the distribution of pine in Europe. If we measure pine here or here or here or here, we probably see quite different individuals because they are growing up in a very different climatic conditions. And also within Estonia, we can find them in sand dunes and in bogs, where they are completely different in size and their physiology and so on. So one of the things to study plants in Arctic is also the reason that you can understand more the functional diversity of it. It should be bigger if you go to further places. And another part of why plants are kind of strange and maybe incomprehensible is that they are modular. And this is something that usually is not really, it's very difficult to understand that every plant is not an individual, but kind of semi-autonomous individual forming a network of something that is an individual maybe. Nobody knows what the individual is. And this modularity can appear in very different scales. For example, if we have an individual of clonal species with those underground ramets or roots connecting different things that we consider plant. We consider maybe this as an individual and this as an individual, but they are interconnected. Also, we have plant parts that are above ground and below ground that live in a completely different world. The soil is relatively stable. There is no fast movements in the soil, no big herbivores coming and just biting you, unlike above ground. And then we can also could compartment or kind of separate plants according to their vegetative and generative parts. So some parts are responsible for getting the photosynthesis energy into it and providing the individual with all the energy in order to also propagate. But those parts that propagate usually are just recipients of energy, but they are not producing energy themselves. So they are completely different strategies of the different plant parts of the same shoot. So some are donors, some are recipients, and I think this is one of the ways how to go forward with this plant functional ecology in order to better understand how plant ecosystems function, starting from the interspecific trait variability. So it's just one of drawn picture, but a lot of species in the Arctics look very similar. This is Salix reticulata, one of the willow species in the Svalbard, and you can see the same kind of pattern that they're just looking for different parts how to survive, and probably the climate, microclimate here might be a bit different from here, and this could be one of the causes of this intraspecific variability. So just to sum up some of the, let's say, constraints of studying plant ecology in a very general way. Usually people study the whole communities, many species, but only in a few or just single geographic location, and focus on just a few what they think are key traits. Okay, I'm not going to go into technicality how to calculate this interspecific trait variability, but this kind of approach has not yielded any actual results of how to understand what this variability is and why it's so abundant in nature. So one of the things that one of the species we are thinking of focusing on specific species in order to find out these variability patterns from there, so that we take a little bit different approach. And one of our target species is Polygonum viviparum or Pistorta vivipara. It has two names. It's a species that has circumpolar distribution. It can be found all those dots here, and the core dispersal or distribution area is Northern Europe. And we have some samples from Svalbard, some from Estonia, from Czech, where Peter, who's going to talk next, was sampling them, and also from northern Spain, where it grows in the Pyrenees. And the interesting thing about this plant is that it has this generative stalk, flowers on top of it, but those things here are little clones of this plant. So they are called bulbils. This is why the viviparum is in the plant Latin name. Viviparum means to give birth alive. So like humans are viviparous species, and some reptiles and so on. So basically these are asexual little clonal kind of bulbils that you can just put in the soil and it starts growing the same genetic individual of the same plant. So we are trying to, our idea was to make like a greenhouse experiment where we measure the variability of the individual in the field and also then the variability of the same genetic individual in the common garden conditions in order to understand how much of this variability comes from the genetics, how much comes from the environment, and how big are differences between individuals. But the guy who is running the genetics lab in our tiny university broke his leg, and he was not at work for 3 months, so we couldn't do the analysis. So that was my plan to show in the beginning, but we don't have those yet. Yes. So, but I just for the last slide, I have another study that we did already 2016 in Svalbard. The first summer I spent there in the Czech station, where we used the same species. So we studied plants in Svalbard and in Estonia, the same species that grow on both of these places. It's Betula nana, vaevakask, very common in Estonia as well. Vaccinum oleaginosum, which is sinicus, also very common. Equisetum, again, very common species in Estonia, põldosi, and the same Polygonum. So there are relatively different species. Some are woody, some are herbaceous, quite old evolutionary, and so on. And we just tried to see how much variability there was in the length of the leaf, because this is the mean leaf length. This is the thing how usually plants regulate their photosynthesis. If they need more light, they make bigger leaves. This is kind of very common way how to do them. And we studied 10 individuals from each plant species, and if we found the individual that we wanted to study, then we made a 1 by 1 meter quadrat around it and measured the species richness of other plants in this, assuming that if there is more species, there is more competition, and that changes also how much you can grow your leaves bigger. So it's like biotic competition there. And if we put all those things together on a one plot, this is the mean leaf length. So we measured, let's say, all 6 leaves of Polygonum or all 100 leaves of Betula, and got the arithmetic mean value. Each one is one individual, all those species together. We see that there is a positive relationship. So basically, the more species around you, the bigger leaves you have, because you need to fight more for the light. But if we measured not the mean actual size, but the variability in size, so it's this variation of coefficient of variation, it shows how much variability in size there is in one individual. We saw that there is no relationship with species richness. And then I show you the next layer, where we divided individuals of Svalbard individuals and Estonian individuals, all the species still together. We see that there is a positive relationship with this absolute mean leaf length in both cases. But in case of this leaf length variability, there was no relationship in Svalbard, but there was a positive relationship in Estonia. So this is different depending on where they are growing, probably related to the absolute size of the vegetation, because usually plants in Svalbard cannot grow higher than about 15 centimeters, because then they will just they are not surviving the winds and the cold there. And if we again put all those species separately, we see that this interspecific variability in this one trait is completely different in all those species, and also the variability itself of those traits are completely different. So it's a very kind of complicated species-specific phenomenon that we have. So it is probably relatively impossible to study it in a tropical forest in order to understand what drives it. So this is this graph is something that kind of, for me, proves that I need to go and study it more in the Arctic areas, because, for example, well, it's a good thing to understand this modularity is when you have crossbreeds of domestic animals, then they are not the mean value of all the traits that father and the mother has, but they have those kind of modular inheritance or inheritance modules that pass on to the next generation. You know, the head comes from one dog breed, and other parts come from another. It's not a mixture of both of them, and this probably is relatively universal in nature and also in plants. So I think this is why it would be good to get to or find out those patterns first in the Arctic, so that we can extrapolate them on all across the world. Thank you. There are no questions, right? Or there are? It's a very strange conference with microphone and makeup and no questions. Okay.
Good morning, everyone. Wow, it's really loud. Sorry. Maybe I can turn it. Yeah. Thank you. My name is Petr Macek, and I'm from Biology Center of the Czech Academy of Sciences, and jointly I'm collaborating with Estonian University of Life Sciences here in Tartu. And I will talk here about the effect of climate change on plant and plant-plant interactions in the high Arctic. Well, first I will go through the effect of climate change a little bit more global way to mention it, because I think everything is maybe obvious, but there are some less obvious changes. And then I focus on my own research. So let's start with the most obvious thing, that the climate during the last century is warming, and everyone acknowledges it, of course, and you all will know about it. The fastest it is in the Arctic, where it also increases in a fast speed, 4 times as fast as the global average. And it influences all the ecosystem functioning. as I said, I will start with obvious changes, which are here represented by glacier forelands and glacier extents. You can see that the purple line indicates, maybe I can show, for instance, this one. Purple line indicates the extent of glacier foreland in 1936, while the red lines indicates the current extension of glacier foreland. And you can see vast areas of sea and land have been deglaciated in last almost a century. There are also some other obvious changes. I will try to ask help for making the video working. Maybe it's not going to happen, but everyone knows the polar bears flowing on the last sea ice and starving there. And the consequence of this is also that these nice creatures are wandering around our facilities and around our stations as well. So it causes quite a lot of troubles and problematic situation for both sides. But apart of these obvious changes, there are also less noticeable changes, like that the seasonal ecosystem respiration increased by 30% in response to 1.4 degrees change of air temperature. And organic matter decomposition and methane emissions are following in the same way. And there is a net impact on regional climate forcing, where we see the positive feedback from the vegetation, especially the taller vegetation like trees and shrubs. They again increase the effect of albedo, well, decrease the effect of albedo, so less sunshine is reflected back by light colors of snow, and more warm is accepted. So we can say that taller vegetation amplifies warming. And here we comes to the vegetation and its role. We define subarctic, low and high Arctic depending on the vegetation. So for instance, subarctic is defined by the tree line, while low Arctic is where most of the shrubification and obvious shrubification, it means increase of shrub cover, is occurring, and where also most of the permafrost is thawing. But I should say that also in high Arctic the permafrost is thawing. Here you can see the permafrost going really to the upper layers of the soil, and it's a picture of a site in 2014, and this year we have been sampling soil cores at the very same place. And the ice was gone, the permafrost was melted. If we follow, oh, thank you, wonderful. If we follow the changes in low Arctic and in comparison to high Arctic, there are two examples, two locations. Let's focus on plants and animals. We can see that in low Arctic, the shrubs and graminoids are increasing, while in high Arctic, most species decrease. And it's in terms of species number, not on the cover of the vegetation, because NDVI, the measurement of greeniness of the environment is increasing in both sides. And we speak about Arctic greening. But there is also Arctic browning. I already mentioned that shrubs are increasing in cover shrubs and trees, and this happened not only in the altitudinal scale, but also in the latitudinal scale. Shrubs are advancing. You can see some location in North Canada, where in '87 there were barely any shrubs. There is something similar, small here. But nowadays, well, 20 years later already, there has been lush shrub vegetation. And it's increasing all over the low Arctic as a response to climate warming. And this shrub expansion has been associated with species losses and a decreasing of richness, plant community richness, as well as species and functional richness and evenness. And it seems that temperature and plant-plant interactions are emerging as the main drivers of the directional change in the Arctic vegetation. When we speak about plant-plant interactions, we usually think about the negative interactions, the competitive interactions, how the plants steal each other's resources. But there exists something completely different, which is called facilitation, positive interactions. Here you can see typical Arctic tree, high Arctic tree, sorry, and high Arctic columnar cacti. The tree is elevating the water from the deep soil layers and redistributing it to the columnar cacti that are growing beneath. Of course, these are from deserts in arid zones. But similar facilitation, similar positive interaction is known from the alpine systems, where it is known to enhance soil resources, milden the climatic extremes, both high and low temperature, and what is most interesting for me, it also increases the species diversity. What is growing inside these cushion plants, it's more diverse than what is growing in the surrounding. And if these positive changes, positive effects of cushion plants are combined with increase in temperatures, then we can expect that, well, it can ameliorate the conditions, and the cushions will serve as a more as a better conditions for beneficiary species. It results in stronger facilitative effect, right? Could be, but and we can think that there will be an increase of individuals, maybe not the increase of diversity, but the increase of individuals, yes. And to follow this, to investigate this, we followed the cushion plant, small one, not as big as you saw in the previous pictures. It's called Silanacolis, and we followed it in the central part of Spitsbergen for last 10 years. And we try to answer the following questions. If there is any specific species or functional shift related to the environmental changes, and how these plant-plant interactions are changing under warmer climate and reduced herbivory pressure. I will explain this later. Well, just directly. Because we used the manipulative experimental design at 2 nearby locations, and we established warming treatments by open-top chambers, but these open-top chambers are also preventing the herbivores to go in and graze, so we establish an intermediate treatment, which is exclusion of herbivores, and of course the control plots. The herbivores that are excluded are these 2 bird species, one resident ptarmigan, one migratory species goose, and cute reindeer that is resident in Svalbard. And we saw that the warming treatment has a clear effect on the snowmelt, for instance, on the temperature inside the open-top chambers. There is an earlier snowmelt in these conditions, and warmer temperature imprints into the phenology shifts of the plants. So plants are flowering earlier, and they are also fruiting earlier, which may be beneficial for them. So first I ask on the species changes through the time and in different treatments. And second, I distinguish the plant-plant interaction by means of relative interaction index. So let's focus on species change. You already saw this plant, Salix reticulata, from previous lecture, so it's nothing new for you. And we can conclude that from this slide that in warming treatments, this line, and also partially in exclosure treatments, the species that grew the best were Salix reticulata and Silene acaulis, discussion species. Also Bistorta vivipara, also mentioned in the previous lecture. Its dominance is increasing in the herbivory exclosures, but not all shrub species are the same. For instance, Dryasoctopetala is not enjoying so much the warmer conditions and tends to be more common in the control plots. It can be seen in this picture as well, where these are the 2 shrub species. I spoke about the shrubification or Arctic browning. You can see that there is the time direction, so more shrub species in recent times, but not all of them are responding positively to warming treatment. They are more toward the natural situation. And in contrast to the shrub species, there are other groups of plants, like herbs, for instance, represented by Oxyria adigena, Erigenion humilis, or Minuartia, which are decreasing in time, and they are more toward the start of the experiment. I will skip this. The second location shows basically similar pattern, and we can say that there is a noticeable species change even in the high Arctic vegetation, and it's both temporal and related to the treatments. Although in both cases, this change is rather small, and it could be this limited extent of this change could be due to the strong resilience of tundra vegetation against climate change. But there is also an indication of functional shift from herb community to shrub community in time. Let's move towards plant-plant interactions. I mentioned a relative interaction index, which we use for basically comparing what is growing within the cushion, how many individuals, how many species, and we compare it with the same area that is in the surrounding of the cushion. And values above 0 of this index indicates positive interactions, while negative values indicate competitive interactions, and the greater the absolute value from 0 is, the stronger the interaction. Oh, there's some nice visualization of this graph, but let's don't focus on these lines. These are some addition. And if you look at the Ramet number in control plots, these are these two, it seems that nothing much happened. The cushions do not represent better or worse conditions in terms of total vegetation. But for instance, exclosures, there is a change, temporal change and temporal decrease of competitive interactions which prevailed before towards neutral interactions now. And slightly opposite trend can be seen from warmer conditions, where the cushions are slightly less favorable to the beneficiary species. There is a similar trend in the other location. Let's move to species number. First, I spoke about Ramet, which means the number of individuals irrespectively of species identity. Now I look at the species number, whether it is there are more species inside cushions in time, and indeed there are, and it doesn't matter whether it is in control or warming plots. There is a temporal trend of increasing species number in cushion plants. So it seems that the cushion plants are promoting the vegetation change. Let's look at one group of species, shrubs. Here in the case of Salix polaris, we can see the shrubification effect, and in all treatments there is an increase of the positive interactions in the cushions by this shrub, Salix polaris, this willow. In another willow species, Salix reticulata, they are growing side by side. The situation seems partially similar, like in control and exclosures, but also partially not. And warming here seems not to favor the extent of Salix reticulata. And if you look at the last shrub species that we have more dominant, Dryasoctopetala, we can see that the trend is completely opposite. And even in controls, the cushion plants are representing more competitive environment for this species, and even more under the warmer conditions. So species response is species specific. It should be taken into the account. It could be due to the physical parameters. I mentioned that the cushions are warmer than surrounding environment, but I didn't mention that cushions, in our case, are also drier, and it means that moisture level can be another additional driver of changes in our situation. So there is a directional change in plant-plant interaction in some species. In general, it's not significant because of the species specificity of this change. And exclosures especially are helping plants to escape herbivory pressure, and cushion then turn to provide more suitable conditions for plant growth. Warming, on the other hand, is providing slightly less favorable conditions, and there are more competitive interactions in these cushion plants. I should mention that our three shrub species are within the whole set of Arctic shrub species, rather intermediate or losers in terms of global range extent, which means that there might be more stronger competitors coming into the Arctic, high Arctic site in Central Svalbard, and there might be more novel communities emerging. I will come to this later. There is a high species turnover in the Arctic vegetation. We see that it's a dynamic system. It's not steady state. It's evolving, and it's evolving not only in species but also in plant-plant interactions. They are changing in time, and it's site, context, and species specific of these changes. And it seems that not only temperature and plant-plant interactions, but also, especially in our case, other factors like humidity could be the main drivers of directional change in both species and functional. There is a clear shrubification, but other groups are likely to follow. There is an indication that the herb species are being more suppressed, and it will inevitably lead to novel communities that will emerge in the high Arctic through either immigration or community reassembly from a regional species pool. And that's why we should study plant-plant interactions in the Arctic, because we know nothing about these novel communities and potential interactions within this new species assembly. Not mentioning the cushion plant role is not much known in the Arctic region, and there are unknown patterns of plant-plant interactions in the Arctic under the rapidly changing climate. Well, now I should just say that it's very important to have a long-term research in the Arctic, and with this statement I would probably thank you for your attention, and thank to all students and colleagues who participated at the establishment and field measurements of my research. Thank you. We still have 2 minutes for questions, and I promise I will not escape as Lauri.
So I have one question about the, it's just a speculation. So if we think about herbivory and role of herbivory in these high latitude ecosystems, do you think that due to the warming, herbivore becomes a bit less because the birds and mammals, they need less energy to spend to maintain the reserves, or because of milder climate, these mammals and birds becomes more abundant and they start to graze down many things? So what is your speculation? So which way it goes, and how important is it nowadays?
Well, the question, I should repeat it because it's recorded. The question is about herbivores, and what is my estimation of herbivore change in dominance in the Arctic, whether they will be less abundant or more abundant. And I would say that the herbivore habitat will change, and they will follow the habitat. So some of them will decrease in numbers because the habitat is shrinking. For instance, ptarmigan will decrease, while other herbivores such as geese, that is migratory and that is enjoying just the summer, they will most probably increase. But it also depends on the other factors like hunting pressure in low latitudes. But we clearly see that the herbivore habitat is changing, and the herbivores are either expanding or shrinking their habitat. So it's not evident, and it cannot be said that everything will change in one direction. The response will be, as in plants, species specific. No more questions? So then I am able to escape. Thank you and have a nice day.
To the next speaker. I'm Maria Kruusma. I'm a professor of robotics, and I come from Tallinn University of Technology, which is right on the outskirts of this town here in the campus. And actually, I'm a professor of IT and robotics and sensorics. So what we do for our research is that we build different things to understand what's going in parts of the world where people have not been able to gather information before that. So we define ourselves often that if you've never been in a place something like that and never got information, so if we can build you gadgets where you can go to places where you've never been before and you never got information. Thank you. Just few of the examples here, for example, is a little underwater robot that goes inside of the shipwreck where it's very hard and very dangerous to go. Or here is a little gadget, what we'll later tell we can also deploy in Svalbard, but we first developed in order to understand river hydrodynamics. Or here is, for example, a robot which is developed for going inside of abundant caves and abundant mines underground, and it looks funny because these little things around it is to emulate a touch sense, because there is very little information down there, and it can by touching understand where it is. Or we have different sensors that we later talk about Svalbard. But also they eventually, in the beginning, they developed in order to understand the river and coastal hydrodynamics here in Estonia or in Central Europe. And then we understood we can also study them elsewhere. But yes, we praise ourselves for actually doing some innovation, technological innovation, but the innovation is often oriented towards having a very rugged, very fault-tolerant, very deployable sensors that are very resilient in different environments. And as you maybe understood from there, we mostly do underwater technologies. So going underwater is difficult already. People think that hardest thing is to going deep on the bottom of the ocean, but it's often not so. It's often so that, for example, coastal regions here in Estonia are much more inaccessible because they are very turbid, dynamic, there is a lot of sediment and things like that. And you also have to make little things in order to go into shallow water. So shallow might be more difficult than go into a deep water. But also even harder than that if you start going out of the water, but you're still not on a dry land. So you're going somewhere like a mud and sediments, and we talk a little bit about that too, that being in those muddy places could be even more difficult. But now you could already understand why we are actually so fascinated about Arctics, is that you probably maybe know the saying that if something works in Arctic, it works everywhere. So it's probably natural for us to go into these places. Once we got a test case that this works there, we can easily go to tropical islands and say, well, this is like already showcased in Arctic, and it works. And Arctic also, we know that you already heard from the previous speakers, there is a lot of changes now going on in Arctic, and we need more data to understand what are the effects of the climate change, how much of the climate change do we have, and to forecast all that. And for that we need data. And there is a peculiar thing with an environmental data. It's kind of things to be that way that if you already have a lot of data, then you go and sample more data from places where you already have data. But you still have the data gaps from places where are very hard to go. And for example, if we have satellite data, we can record data from surfaces, from an Earth surface, from a sea surface. But if you go under the surface, it's much harder to get data. And for example, you can have some sensors somewhere under the surface, but this just gives you one measurement point. It doesn't cover the whole area. So there are big areas of Arctics and Antarctics where you simply have no data at all because there are no technology, or it's too expensive in order to go there and gather the data. And similar is going to the bottom of the ocean, is going under ice, same thing, and also polar night. Just deployment, recovery, but also if satellites, optical satellites not working in a dark, then you again have a data gap. And in order to fill this data gap, it's not just building devices, but it means like you have to build rugged devices that will endure the whole polar night, for example, and the other things that are inexpensive enough you can actually afford having those devices. And that's also a very big thing. And finally, as the previous speaker said in the end, that what scientists really want to see is long time series. And well, long, it depends what is long. Sometimes long is weak because it's so hard to measure things, but sometimes it's years or sometimes it's decades, but the longer the better, right? So what we need is long time series, but we would also like to have a nice spatial resolution. If you have like one data point, one sensor somewhere in the middle of the polar sea, that just gives you one measurement, but you would maybe want to have 100 and you don't have them. So I present you two cases where we in Arctics try to get data from places where you normally don't have data from. And the first one is a glacier meltwater path. We already saw in a previous slide how glaciers are retreating. We try to understand the glacial dynamics. Why are they retreating so fast? Are they going to retreat faster? Are there any threat in places where also humans are living, because glacial retreat might make the glacier unstable? And for that, we need a lot of measurement from the surface of the glacier, with seismic sensors, with lubrication of the glacier, with the a bed of the mountain, and so on, and so on, to understand the dynamics of the glacier. So from where we often don't have any data at all, we've never have ever data after all, is a glacial meltwater path. What happens inside the glacier when the glacier is melting? So in summers, the glacier is always melting. So there are going to be these little tracks of meltwater, like little rivers appearing on a bed of the glacier or the surface of the glacier. And then at few points, this water is just disappearing because it's falling into big holes, moraines inside of the glacier. And then basically nobody knows what's happened before this water comes out from the other part. And between this part, when it goes inside of the crevasses and coming out from the outlet of the glacier, it's basically unknown what's happening. And what actually happens there, we sometimes get a glimpse when we go there, like in the middle of winter, or if the channel is really big, it looks like the big water slides in a water park. So there's a lot of water going with incredible speed, and you can imagine how much energy is in that, and all this energy is going inside of the glacier. Definitely changes the dynamic of the glacier. So from a point of view of understanding how the glacier is behaving, it's also important to understand what the water is doing inside of the glacier. So our answer to that, as we are technology people, we build gadgets, was that, well, we build gadgets. And we put the gadgets inside of the glacier, and then we thought that if we let them flow or drift with the water and some catch gadgets, and we understand what are these things actually recording. And this is a little sensor which actually contains a accelerometer and a compass and a pressure sensors. And if you see it's going with the flow, and here you could also see that it measures, for example, in this case, pressure. And after a while, when it just keeps watching the whole thing going, then you can see that, if there is, for example, a pump in the channel, it suddenly falls, and you could actually see also a pressure drop somewhere, and you could see it from the acceleration. Or when there is a very lot of turbulence, it behaves differently. And finally, if you're watching those things for a very long time, you start understanding the nature of the channel. What is this water actually doing, sir, just by looking at this data? But that's not enough, because this is a description, right? You could look and say, okay, there should be a little waterfall, but you can't really quantify the thing. So what you actually need is to take the signal and then analyze it mathematically to understand what's happening to that, to have a quantitative description of the glacial meltwater pathway. And we thought, of course, it's a easy thing to do. So we went to Svalbard, and we actually ended up working like 5 summers or something. Not all of them were equally successful. We first thought that it's not a big thing. We just drop our things into the channel, and so go to the outlet of the glacier, and then we just wait, and then the things are coming up. And then we catch those things, and then we read the data, and then we start analyzing the data. I go, for some reason it's not working anymore. Okay, but you can imagine, it's funny, it's working here. Let me see, let me fiddle around a little bit, maybe I get the video working. No, not, unfortunately, you can't see the video. Yeah, you can see the video, yeah. At least the beginning of it. So, yes, it worked, yeah. It worked out in some years, and some years it didn't, because we lost all our sensors. In some years we caught the sensors. We ended up developing it further and further, because we understand that once you drop somewhere in Arctic, and finding it is very unlikely in the end, that you have to be very fortunate to find your things. first 2 years we got very good data from New Iceland, from a nearby glacier, Östra where we find a very nice channel and we drop our things in, and then we found at least like 70% of all the sensors we dropped in. Then we went to Kongsvägen and there was a big glacial lake burst, and we tried to investigate that for 2 summers, but we mostly lost all of our sensors. And since the sensors went to Austfonna with a research ship, and we got very nice data from there as well. So having all this data means that in the end, once the field work is done, it's a lot of work already, but actually for us, this is where the work begins, because now we're sitting on the top of like hundreds of gigabytes of data, and we have to do something with that. And that's basically what we start with, is developing mathematical algorithms, taking all these sensor information, the signals, and then understanding what is happening. And that's actually is maybe not so obvious, but this is actually where robotics comes to play, because it's a very standard problem in robots. You don't know when you are, and you have to find your way, and you have to localize yourself when you're a robot. And you don't have a global reference, you don't have a GPS, which you don't have in a meltwater channel. So first GPS point is when you drop something in, and the second GPS point is when you take it out. And between those points, you actually don't know where you are. And what we sent to is that we apply machine learning algorithms to make a probabilistic reasoning. What is the most likely path which we are taking with those sensors? And especially if we have many sensors going and there are similarities, then we could take that this path is more likely than the other path. So we never know for certain, but we are certain that we are completely wrong neither. So this is a nice thing with the probabilities, that we are also, it's probably that to some degree you're still right. And in this little video here you can see a reconstruction of a glacial meltwater channel in Östra in New Iceland, and the colors indicate the pressure. So it's sometimes it's more pressure, sometimes it's less pressure, which is also, and you could also have the same for acceleration. So these are all kind of a indication how much energy the meltwater water puts into the glacier and changes the dynamics of the glacier. Pressurized glaciers are specifically interesting. We never had a chance to investigate them because we always lost all our things. But sometimes the pressure inside of the glacier becomes very, very large, and that could even lift the glacier up from the bed of the mountain and just simply put it into a different place. So these are the places where the glacier becomes unstable and are extremely important and interesting to investigate, what we also would like to do in the future. But so far we have some good glimpses into the places where nobody have got data before from inside of the glacier meltwater pathways. So this is one data gap that we probably have been able to fill in with our technologies. And the next one I would like to tell you is about investigating coastal dynamics in ice fjord and in Svalbard for the last 2 years with Rico Normets, who is also a speaker, and he fills you in more with all the scientific background, why and how to study coastal dynamics. As I said, we are mostly the people who provide here the technology, and this is, I think, for say first Estonian financed polar campaign during the Estonian Republic, our new independence now, where we come to Svalbard, and financed by Ministry of Foreign Affairs, were sent to go there and deploy our sensors and then later recover those sensors. We still all look happy there because we just had a very successful deployment, and we were hoping coming back a year later and understanding better the coastal dynamics. So what's added value with this technology is that if you take this place here with this ice fjord and the little branches of the ice fjord in here and look at it with a Copernicus, since that would be just probably one data point on a satellite data. So you get just one point understanding. This is, for example, on June 24th, this was the speed of the height of the waves and the speed of the winds or something like that. But actually within that region, the speeds and wave action and currents, they vary a lot, but we cannot see it with the resolution that the satellite is giving us. And this is now where we're coming to the data gaps. If we want to understand with a better resolution what is actually going on in a fjord like that, then we need more than one data point. We need many data points at the same time, and as a previous speaker was also emphasizing, preferably we should measure for a very long time to understand what is actually happening. And here are different deployment points that we have in different branches of the ice fjord. And first year we deployed 9 sensors, we recovered 6, we were very happy, we thought that this is a very good recovery rate. Everybody who works in Arctic knows it's a very good recovery rate. And this year we were back in Svalbard and we were looking for our 6 sensors left and we recovered 0, so this wasn't that good recovery rate. But anyway, we ended up with a very good data for the whole year's period, which is quite unique on this sort of resolution. And from a technology point of view, there's actually one more thing to emphasize is that doing polar research costs a lot of money, like a lot of money, and equipment costs a lot of money. But in this case, also the cost of the sensor was not very high. It was actually quite cheap. So we mostly regretted not losing the sensors, but losing the data. And it's also a way of making polar research more affordable. If you have cheap sensors, you can deploy them, many of them, and then you can also afford losing something without bankrupting your research team. So that is a good thing. Here is now our sensors put on the seabed, and this is the sensors which is recovered a year later. It has a little kind of rod in on the top of the sensors there. So the innovation here is that we can measure without acoustics. We can measure mechanically the wave action and currents. What happens is the water moves, then the stem here starts vibrating, and from the vibrations of the stem, we can actually figure out what is a speed of the current and what is the direction of the current, and also what is cycles of the wave action. So here, for example, you could see a longer measurement period, and here if you zoom in, you can also see that within like 1 day and 1 sensors, how actually the signals, the flow velocities in this case, changing like with tides and currents and with a wave action. And of course, what you actually, if you're a physical oceanographer, what we'd actually want to have is what you call a high energy event. So what actually makes very many changes on a coastal region are the storms. But it's very hard to go to the coastal region and to say, oh, the storm is coming, I'm putting my sensor in there, and when the storm has gone, then I go and take it out. So it normally doesn't work that way. But you need to have something that works reliably, works for a very long time, you put it there, and then it just sits, and then it just waits. And waits until the storm is coming and starts recording. Or records all the time, it doesn't matter. But what you're really interested in are the high energy events. So you want to understand what is actually happening, where there's a lot of energy around the coastal regions. And why is it important? Also, the next speakers are going to talk about is that if you have a lot of energy in the coastal areas, then the sediments are replaced. And how it exactly happens, you have to make an interconnection between the sediment analysis and bathymetry analysis. How is the coast and how is the bathymetry, the coastal profile, bottom profile of the base, and then match it to the sensor data of the wave action and the action of the current, which gives the possibility to understand and to model how the sediments are moving. But also when you're able to model, then you also know that you can predict how the sediments are going to move in the future. And in this case, why it's important in those areas of Svalbard is that Longyearbyen is the biggest inhabitant of Svalbard. So what happens in Adventfjord really matters to people who live there. There is a little community, but really if the coast is changing with the climate change, they need to know that. And this kind of a measurements give actually understanding what is happening to their homes with the climate change. But now if you zoom out to the whole Arctic, and there are a lot of many settlements like that, for example in Greenland and Svalbard and north of Norway, mainland Norway and elsewhere, where those things are happening. So you can think of that if I have now this very high resolution understanding how the glaciers are providing more sediments, how the sediments are moving, how the storms are changing, how the direction of winds are perhaps changing, and I'm able to model it, then I could also be able to be prepared to the climate change for the local communities in the Arctic. So these are now the next things we are going to look very closely to the data that we have gathered and understand and predict what is happening in Adventfjord and maybe also elsewhere in the future. So just to cap it up is I think that there is a lot of that technology could provide to help data gathering. It's not just making more sensors, but it also means like making more innovative technologies, different kind of technologies that were not there before, in order to measure cheaper and more reliably and with a better resolution. And I've talked a lot about deployment and recovery, because this is, what we've been doing and takes a lot of energy. But actually, we also understand how important is everything to do with the data management, and all the polar researchers have a lot of work there to do, a lot of work here to harmonize the data, to work on the protocols, to work on the standards of the data, so that one data collected by one researcher is findable and usable by the other researcher, and so on. But even more, in our research group, we also work on pipelining the data. If we take data from a place like this glaciers, and it takes us about a year to process that data, which is very little, because when Amundsen went to the North Pole, it took 20 years for him to go later on through all of his notes and actually publish those things. So things are actually moving faster. It did like 100 years ago or so, but we'll still, what we would like to do ideally is that when you come away, when you come home from your polar expedition, or somebody else gathers from data, your paper, so to speak, is already almost ready, because all the data processing, pre-processing, filtering, modeling, predictions is all automated. It takes very little time. And right now it's not the case. Very often it's not the case. It takes very long time, and the data quality is a very big concern. And I also think that, coming myself from a background of IT, and I know in Estonia there are a lot of people who have a good experience already and a lot of expertise in data handling, data processing. There is actually a very good research gaps that we could fill in with this data automation, data processing technologies. And this I also can say is there, if we find those gaps, which at the moment are crucial, then small nations might have a much bigger role to play in polar research that would have been anticipated by their size, because if we could bring to the polar research exactly those little missing building blocks to better understand and better predict the climate change. With that, I would thank you for listening to me, and if there are any questions, I would be really happy to answer.
Kadri Tamm, Department of Energy Technology, and I'm very happy to see that my university colleagues have done fantastic work. But I still have a question about the sensors. And the loss is quite high, and there's still somewhere. Is it that possible they still collect data?
Yes, they probably do, because we've had cases in New Orleans that somebody found our sensors a year later in New Orleans, just on a coastline, and the SD card was all intact, so we could read out data. So it's the question is finding it.
But still, is that data is also losses, or you still put it in your mathematical models, or?
We could probably retrospectively do that. Yes.
Mm-hmm.
Yes.
Okay, that's good news.
Yeah. Yeah. Thank you.
So, hello again, everybody. My name is Martin Liira, and I'm coming from the Geological Survey of Estonia, where I work as a marine geologist, but also I'm a lecturer at the University of Tartu. Today I would like to say a couple of words about my passion, marine geology. And marine geology, but before that I would like to stress that for me as a geologist, Estonia has been always part of the Arctic. About 20,000 years ago, Estonia was covered with a glacier about maybe maximum about 1 kilometer thick, and after this glacier retreated from our land, it left new terrain in our land, and it's mainly modified by the glacier processes. And the same processes we can see happening now in Arctic regions are actually present here in Estonia also, like those plow marks, iceberg plow marks in the seabed sediments in the Barents Sea or in Baltic Sea. They principally are the same, only the age is different. So in a way, we are part of the Arctic. We are part of this large system. Marines, oceans and seas represent one of the main sinks of sediments eroded from onshore. So by layer, they kind of like preserve the past history. As shown here in an upper picture with a seismoacoustic profile of one sediment layers. So going deeper into these layers, we sort of go back in time and we can read what was the conditions, environmental conditions, atmospheric composition, pollution levels, and etc., during that time when those layers were deposited. This process is universal in accumulation basins around the world, in the Arctic basins, but also in the Baltic Sea. Here we can see, for example, the heavy metal profiles in the Baltic Sea sediments, where by dating those sediment layers, we can go from nowadays back to the early last century, where we can see that during the 70s and 60s, where the pollution was very heavy here in Baltic Sea countries, we have a maximum of toxic elements in our sediments. Later, when we agreed among us that we should take something up, we should do something about it, we agreed to reduce the pollution levels, and actually we can see that trend also present in our seabed sediments. So studying seabed sediments, it offers us a glimpse into the past histories. My journey into the Arctic started from this place. Many of you already know this is the University Center in Svalbard, where I had the honor to work together with Rico Normets. But to study Arctic is, as we well know, is very, very important, because Arctic is going through very rapid changes. One of the good examples how rapid and how strong these changes are, actually, if we look the extent of sea ice extent in the Arctic Ocean. Starting from mid-19th century up to nowadays, we can see that the maximum extent during the September month has been decreasing very rapidly, and the change is significant. Even if we look the shorter time span, such as the approximately last 50 years, the retreat of sea ice is absolutely evident. Although some years have better ice cover years and some are less good in terms of sea ice extent, the overall trend is quite clear. And it's quite clear that quite soon in the future we will have first summer in the Arctic Ocean where we don't have sea ice in the Arctic Ocean. And of course this is due to the global warming and the increase of greenhouse gases in the atmosphere. Just to remind you that this global warming is not universal. It's not the same everywhere in our Earth. But we have regions where the temperature increase from the previous is much larger compared to what it is in the rest of the world. Especially in the Arctic region, where temperatures are increasing 4 times faster compared to the rest of the world. And this phenomenon, Arctic amplification, is due to different reasons. Of course, the increase in greenhouse gases concentrations, but also the decrease in albedo in Arctic region helps to amplify the temperatures in Arctic. If we talk about the greenhouse gases, of course, the main driver is CO2, but also methane is a very, very potent and very strong greenhouse gas, and its levels in our atmosphere are steadily increasing. Here in this graph shows couple of key things about methane in our atmosphere, where if we look at the northern hemisphere and southern hemisphere and the methane concentration in our atmosphere, we can see first of all in a timeline that those maximums are steadily increasing. But the most of the methane in our atmosphere is in the northern hemisphere, and it's not migrating to the southern hemisphere. There are several reasons. Of course, most of the land is on the northern hemisphere, but also in the tropical zones, the tropical zone effectively breaks down the methane molecules in our atmosphere, and so preventing methane to evenly distribute across our globe. Meaning that all the methane which is produced in northern hemisphere will stay here on northern hemisphere and increase the Arctic amplification in that region. There are many sources of methane. Of course, melting of or thawing of permafrost is a very big source of methane. And some other processes also producing a lot of methane there. But seabed sediments are also one of the sources of this potent greenhouse gas. Already in the mid-last century, when the seabed mapping started to use more developed technology, they started to notice that in the seabed sediments we can see here and there these small pits or craters, which can be quite large, up to a couple of hundred of meters, and be up to tens of meters of depth. These craters, they are called pockmarks. Sometimes they can occur in large clusters in a seabed where you should have a smooth and cozy and silent seabed. These craters or pits are believed to be kind of like a conduits of fluids seeping out from a seabed, and that's why creating these pockmarks. These fluids can be, of course, usual groundwater or meltwater or these kind of things, but also the overall warming of the Arctic destabilizes also the methane and other hydrocarbon gases in the lower levels of the seabed, and they start to migrate diffusively upwards, and in some cases creating these pits or craters. So it means that whenever we see these kind of pockmarks in our seabed, there's fair to ask, are those pockmarks still, what kind of fluids they are seeping? Is it a strong, do they contain strong greenhouse gas methane, or are they just at the moment inactive and not seeping the methane there? One of the most active systems in the Arctic, where sea and land come together and where most of the sedimentation occurs, are the different fjord systems in the Arctic regions. Arctic fjord systems like this one here, Eastfjorden, where also Maria talked about, the biggest fjord system in West Spitsbergen Island, is very dynamic system, and in general the key environment for the sediment accumulation and also related processes. This Eastfjord has been mapped very thoroughly by previous researchers, And during this mapping, the mappers discovered a lot of pockmarks, these craters or pits in the seabed sediments, these yellow dots here. There were over 1,000 of these craters there, and it was believed to be an escape route of the hydrocarbon fluids. Especially considering that Svalbard has an active hydrocarbon system geologically linked to the Barents Sea oil and gas source rocks. So it was fair to ask, are those pockmarks still seeping out the strong methane gas from the seabed to the water column? And in shallow environments like in fjords, we can't rule out that some of the methane, if it's seeping to the water column, can escape the water column also to the atmosphere and increasing the Arctic amplification even more. For that, we collected a lot of samples, a lot of coarse sediment samples. We measured the methane concentration in the system. Fortunately enough, at least for a global scale, we found the methane levels in those pockmarks are relatively low, indicating that at least in Eastfjorden system, those pockmarks are inactive. They are not seeping actively methane gas. Probably what happened was that the biggest gradient for the seeping of methane from the sediments happened just after the deglaciation, when the pressure drops in the systems were the highest, and probably the most of the methane were lost during glacial retreat. However, we have an indication that at least to some extent the seeping gas from these sediments are thermogenic in origin. It means that the same gas, basically the same gas we are exploiting from the Barents Sea oil and gas fields. However, like I said, fjords are dynamic systems, and the first basins where the sediments start to accumulate after the erosion from inland. So it's very important to understand what is happening in these fjord systems in terms of greenhouse gases, but also in terms of other components like nutrients or potential harmful components, and so etc. For example, phosphorus is an important nutrient for the life, but it's little is known about how climate change and increase in erosion from on land affects the phosphorus cycles in those fjord systems. And these fjord systems, due to climate change, are being extensively affected by this increase of erosion. And sediments, of course, affect what is happening in the sediments. Of course, this affects also what is happening in a water column. Just recently, we conducted research of 2 fjords north of Svalbard and next to New Ålesund, and also some shelf areas where we collected samples, especially to study what is happening with the phosphorus and other nutrients in those systems. Not surprisingly, we could see that in the fjord systems, the organic carbon concentrations in the surface sediments are quite high, comparable to the open shelf sea sediments. A little bit surprisingly was that the level of nitrogens in the total nitrogen in the fjord system, but also in a shelf sea, are relatively little, indicating that the nitrogen could be having bigger effect to the local ecosystem. Lack of nitrogen could have a bigger effect to the local system. increase from a fjord mouth from inland to outer part of a fjord, clear indication that closer to a glacier front, the organic carbons. Organic carbon concentrations closer to the glaciers are relatively low and increase towards the outer part of the fjord. However, this is quite well known, and but what is less known is how the phosphorus is acting in the fjord sediments. The story of phosphorus is a little longer. Usually we think about phosphorus as just one element in our system. But if we look more closely, we can actually divide this phosphorus in our sediment systems into the different categories. Mainly we can divide those that phosphorus as immobile, inactive, vis-a-vis the yellowish bars here, or mobile and active. I mean mobile, that's the phosphorus forms which are useful for the ecosystems, which can diffuse back from a sediment to the water column and increase the bioproduction. These two stations here represent the typical seabed sediments where we have roughly half or more than half of the phosphorus in the sediments are immobile forms. They are not actively anymore related to the ecosystems. And we have maybe up to 40% of phosphorus which is mobile. And from this 40% of mobile phosphorus, majority of that is bound to the different iron minerals. Iron is usually the biggest fraction of the mobile phosphorus. However, if we go into the fjords, we can see that the phosphorus bound to the iron is the proportion is much less compared to the proportion of the most labile phosphorus form, which is very effectively diffuses back to the water column and can affect the bioproduction there. So indicating why is that? Probably this is related that the sedimentation rates are so big that even the diagenetic processes which convert the labile phosphorus from one form to the iron form are still not happening because the fresh materials are put on into the fjord system. How this system will act in the future needs very close attention, and probably we should do and more campaigns to see what is happening in these fjord systems. So this is ongoing research. Lastly, I would just say a couple of words. I would like to say thank you to my fellow members of Polar Club, and just to point out that, like Mario also said, it's very hard to do research in Arctic. It's very costly, and it's time-consuming, and due to the remoteness and other issues. And I was extremely lucky that I could collaborate with sailing yacht Admiral Bellingshausen crew on the Arctic voyage in 2021, where in a citizen science campaign, Maris and Tiit Pruuli were kind enough to collect me surface seawater samples from the exceptionally large area during the cruise on different, and I was able to study them and to see how many hydrocarbon gases, methane especially, are there in those water layers. Fortunately enough, everything was normal, and we couldn't detect any higher levels of methane gas in the water column, which in a way is a good news. However, just that was a couple of glimpses into the sea sediments and why they are important. And believe me, they are very important. Thank you. Are there any questions? Maybe one? Oh dear, I used all my time. Sorry for that. Thank you.
Good morning, everyone. First, I want to thank you, the organizers, for inviting me here. I want to thank Martin for a fantastic introduction at the beginning of this session, of course. And I also have to thank the organizers for the title of the talk, because this is not a title I would have thought of myself, because I was always under the impression that Svalbard was quite centrally placed, and then deciding from the previous talks, I think it is quite central. So I don't know what age, or what is that age, but we'll see. We'll start talking, perhaps we'll find that age and then see how close to that age we will get. So this will be by no means a traditional science talk like the previous ones. So if you're here for heavy science, please feel free to leave and go take an early lunch. Will not be held against you. But if you want to see some nice pictures and hear stories, well, nobody's leaving, so I guess nobody's interested in science here, really. I mean, but then what I'm going to do is basically take a little walkabout in Svalbard, show. Give a sort of a short introduction to uni, sort of tell about the history, how it got started, how it has developed, what it is today, what we do there. And then towards the end, as much as I have time, to tell a little bit about the research and the research collaboration. Some of that was already mentioned here by Marian and Martin, with whom we have worked for years, but there is a lot more also with Estonian colleagues here. And tell a little bit about that research, and that acute part of research that the communities, small communities like in Longyearbyen are facing now, especially considering these sort of rapid changes in the environment. But since it's been a while from my last talk here in Estonia, and then this is my first engagement for the Estonian Polar Club, which I actually learned about 20 years ago from Bob Headland when I was still a postdoc in Cambridge. But it is my first talk here for the Polar Club. I'll say a few words about myself as well. So I am a marine geologist by education and training, and I work with a lot with seafloor mapping using different geophysical methods, sedimentological methods, and I use these data for studying the modern processes in the Arctic ice ocean interactions, but I also use these data for longer term reconstructions of glacial history, climate history, paleoceanography, these sort of things. And I work at the University Center in Svalbard since 2008, but my first time in Svalbard was actually a couple of years earlier, so that was in 2006 on board of the British icebreaker James Clark Ross, where we had a fantastic cruise to basically around the Svalbard, and that was the first seafloor mapping, scientific seafloor mapping in Svalbard waters. It was a fantastic weather for 3 weeks. It was calm. The sea was like flat like a mill pond, so it left quite an impression on me. And it wasn't then a surprise when about a year later, a position in marine geology became available at the University Center. So I applied. They invited me over for an interview. I flew up, and by the evening of the same day, then they offered me a position there. So I then went back to Cambridge told my wife that, well, start packing, we're going to move to Svalbard now. We've been offered a job there, and that was a 3-year contract, and that was 16 years ago. So this is how it happened. But since then, since I've been at the University Center, there have been many more cruises after that. James Clark Ross cruise in 2006 on different vessels, from icebreakers to these small autonomous robots that we've been using to map the seafloor, map the glaciers in different parts of Svalbard. And after 16 years, there is still fjords I haven't been to that are completely uncharted, so there is a lot of work still to be done. I don't think my lifetime will be enough there, so that somebody will have to take over at some point. The University Center in Svalbard, when we talk about the research and the education, it's quite central there. It started in 1993, and it got started from a political decision, and it's been said that this was a fastest political decision-making process in a modern Norwegian history, because its decision was made in 1992 on a so-called study cruise. It's a very nice format when it's about a week-long cruise on board of a vessel into the fjords of Svalbard somewhere. And into that cruise, then there are people from, there are like decision makers, there are politicians, members of a government and the parliament who go there, and then there are scientists, members of local community, and then this is where they meet, talk about Svalbard issues, and at that point there was, of course, one driving politician, member of parliament at that time, who then decided that, well, now the time is right to establish a center in University Center in Svalbard. And the motivation was really to promote the Norwegian polar research there and to take advantage of these unique conditions we have in Svalbard in terms of studying Arctic. And of course then to diversify the local community as well, because you have to keep in mind that the Longyearbyen was built on coal, so it was a very like a coal miner's town from the beginning. So there wasn't a lot of diversity of activity or economy in that community. So that would be like a new pillar to provide a ground for like a family-based community in Svalbard. So this is how it all got started. This is the University Center today. Martin showed you already. So the original building, actually, this one. And of course, I mean, in the beginning, the political decision-making can be fast in 1 year, but you don't build a house in 1 year. So the first 2 years, UNIS was actually operating on rented rooms, and then this building was built in a few years later. And then in 2006, the UNIS had already grown too large for that building. So an extension was then built, which is about 2 to 3 times larger than the original building here. And of course, I mean, the initial growth was fast, and because of the fast growth, there are always growth difficulties. It was a common joke that the UNIS was like a kid who was sort of growing from the childhood into the teenage years, and all these mood swings and stuff. So we developed our course programs. We got too enthusiastic. They sort of offered too many courses. That exploded the budget, so we had to cut back again. And so it was going a little bit of back and forth. But UNIS's purpose has always been to educate the next generation of Arctic experts, and that has not changed. And just recently, sort of a Svalbard white paper came out, Svalbard melding, and this is where the government sets its or gives his vision for Svalbard and a kind of a mandate for the people who are there, and there is a role of UNIS is rather clearly stated now. Today, UNIS is I also have to say that UNIS is it's a rather unique organization. So although we are University center, we are not a full accredited university. That means we do not have our own students, we don't issue degrees. So all the students who study at UNIS, they have a home university somewhere else. It's either in Norway or somewhere else in the world. So but we do teach ECTS affiliated courses. That is that the credit transfer back to the home universities is fairly easy. That's the streamlined process. And then the new building added in 2006, that's quite a architectural pearl in itself. I mean, it's lots of wood with glass and copper elements and open spaces, not the single straight angle anywhere, and it's not most logical either. So it's fun to see the students come in and struggle for the first week always to find the lecture rooms and labs in the building. So we have 4 departments: geology, biology, geophysics, and technology, plus an Arctic Safety Center. And today we have about 850 students a year at the University Center. They're not there all at the same time, of course, because we usually have a full semester undergraduate students, and then we have graduate students, master, PhD students, who come, and for them we offer so-called block courses. So these are 5 to 6 week long intensive courses, and then the students can then either pick one or several of those from our course offer. Courses are very popular. Most of them have a rather long waiting lists. Very international, 40 plus nations are present. About 50% come through Norwegian universities, and another 50% are international. Teaching language in English, and given the size of UNIS, then we make up a pretty big portion of the Longyearby's population of people, including students who are then affiliated with UNIS. So about 1/5 to 1/4 of the population of Longyearbyen. So we are quite a big player in the local community. So here it is, UNIS, the old part is there. This is all the new part built in 2006. But there are also other buildings in town that are then either part of UNIS or affiliated with UNIS. So UNIS also started a sort of a housing program for its staff and employees, because Longyearbyen is it looks like a normal Arctic little town from afar, but when you come there, there is no free housing market. You can't rent or can't find an apartment to rent on a free market. So it's quite difficult to settle there. So all the housing is provided through your employers in Svalbard, and so does the university. The university has a very nice little guest house for our visiting guest lecturers, like Martin has been coming up there, and I think Maria has stayed in there as well. Just a few years ago, a new student housing was built. That's for all our students. So it's a quite a nice town. So there is lots of the hospital here. There are lots of pubs around here, even a church somewhere down here. So everything is there basically, and the students seem to like it very much. I mean, then it's very easy after the classes, go climb on one of these mountain tops, and then you go ski down, and then go home and then cook a meal and stuff. So they are just sit in the snow and meditate, or work on your suntan, or I don't know what these guys are doing. Sometimes it's difficult to tell what goes about in student heads, but they definitely seem to be enjoying, and so they're definitely happy. I mean, I know that girl is happy about getting 2 sea ice cores and then going back to the lab, and that sometimes it's all you need for happiness. And if you don't believe me, try it yourself. Go get a sort of couple of sea ice pieces and take them home and see if it works or not. But anyway, my point is that it is very student friendly, and the Longyearbyen was voted by the students for 2nd year in a row now as the best student town in Norway, and you see, Oslo came 3rd only, so it's actually pretty good. So we are happy about that. But as been now mentioned by Maria and Martin several times over, is that all these field work, field-based, and then UNIS is all about field-based education. We are very aware of that the university center was not built, to bring students up in the Arctic and then put them in a classroom and then only show the Arctic through the window. So we take them out in the field as much as we possibly can, but that requires equipment, logistics, training. So and actually most of that new extension that was built 2006 to the UNIS is all about logistical spaces. So that's where we have the clothing for field work, boots, helmets, overalls, all the field equipment, also some laboratories. And our logistical services have become very efficient over the years, so they can put several groups of students per day. We have 20, 25 people in a group. We have example here. This is what students should check against, so this is how you should look like before you go out. And they're getting better and better at this. So we provide everything that is needed, but the training is also a big part of it. So you have to know what to do in a field, how you behave. And our logistical services have also then developed a kind of a module-based safety training. So it's given at the beginning of every semester. It takes 1 full week, and you learn a lot there. I mean, they can students are taken out. They can practice either the glacier rescue or snow and avalanche rescue, snow scooter driving, polar bear protection, small boat operations. It varies a little bit of the time of the year when you come and what sort of field work you're facing, but these are very practical hands-on training. So you go out there in a field to how to drive a snow scooter. They on purpose, dig the snow scooter into the snow, so you have to dig it out, and then you see how hard it actually is. So this is all that goes into the education, and then we actually have a courses developed along these lines. You can get study credits for these courses. Plus, how to keep if somebody falls into the sea or through the sea ice, how to keep them warm and until the rescue arrives, which can take a long time in the Arctic. In terms of research and teaching, they are, of course, very closely integrated. So we teach what we do the research on ourselves. And there is actually, we're kind of a niche university in a way that we teach environmental and Arctic sciences only. But that then is like all across the board, from the space physics and atmospheric processes, including the northern lights, to, of course, geology. Well, Longyearbyen was built on coal, so it started all from geology, oceanography, meteorology, glaciology, so on and so forth. So there is a way. There is like 2 more lectures on that alone. But I have like 2 minutes left because of you, Martin, because you spoke too long. So now I go into these couple of research topics, and I skip the slides I had on you because that's as a punishment for you. Then it's talking too long. Couple of examples of the research we do, and then I chose 2 projects as examples which are most relevant to the Longyearbyen as a local community, because we are a big player in a local community, and we are expected to also provide services and be part of that community. So it's not only the basic science we do, there is a lot of applied science and also looking into the future and helping in the adaptation to the environmental change that is happening, and also not least this change to the shift to from the coal to the renewables, and that is it sounds easier than it is done. So I have 1 minute per project, roughly. One is the snow and avalanche research that kind of got a lift up, and that happened in after the 2015 and 17. There were 2 avalanches that came down this very slope, and then there were 2 fatalities in the first avalanche, and then the second one just destroyed a couple of houses, and that happened during the very warm winter. It was a period of about a week. It was very warm, a lot of snow, a lot of wind, and that packed up the snow along this slope that then eventually came down. And that had never, avalanches are normal there in Svalbard, but they never hit down that hard. And of course, that did some damage in the village. And then that, of course, triggered a very rapid response, because it had 2 people died in it, and that should not happen. I mean, it's when people die, it happens. It happens almost not every year, but people do get caught by avalanches, either by hiking or snow scootering, and then field studies were commenced. There was sort of in collaboration with Telenor, on a real-time snow depth sensors were put out on the slopes, and a lot of modeling studies were done. And then the areas were determined which were most avalanche prone. And then there the snow fences were put up. This work is actually still ongoing. There is a big stone wall was built at the foot of the very same slope, and it's all to protect the houses from the avalanches. And then Longyearbyen is now part of the avalanche warning system as well, so we get daily, from November to May, we get a avalanche warning or avalanche forecasts for 24 and 48 hours on a daily basis, so we know though this situation is now monitored very closely. There is also a large reconstruction of the riverbed, because the glaciers are melting, and especially in the beginning of the melt season, when there is a lot of snow melting, lots of water in a system, the river can rise quite a bit, and a big part of the town is all built on a riverbank here, basically. So this is prone to flooding, for instance. And another little ravine here, which is famous for its slush avalanches. And you see all these walls here. This is also constructed by a man here, and there are lots of snow fences also put into that ravine. It's all to prevent these slush avalanches to hit the town. So that's the ravine. But I don't know, I think I should break here, because the clock is going nervous there, it's blinking, and I think the lunch may be waiting. So I don't know if I'm allowed another 3 minutes or not. If not, then I'll break. Okay? Okay. Thank you so much. And then another project I want to mention here is the Longyearbyen CO2 lab. And that started about 20 years ago. Well, it's about the same time when I went there, so 16, 17 years ago. And in the beginning, that had a noble goal then to make Longyearbyen an emission-free town. And that was then to capture all the CO2 that is coming from the smoke pipe of the local coal-fired power plant and inject it back into the ground. And for that, then they drilled like 8 boreholes in total. I think the deepest was about 1 kilometer deep. And of course, the geological structures they found were very suitable for such a carbon capture and storage project. So there is a reservoir rocks below, like a relatively high porosity, low pore pressure, suitable for pumping in more CO2 in there. And these were covered then by so-called cap rocks, like shales, tight rocks that would then keep the CO2 from escaping. Plus, we had in the Arctic, we have a secondary seal in terms of permafrost, which also keeps the gas in the ground. What they didn't expect is that two of these wells that they drilled, they actually started to produce methane and in quite significant quantities. So this is one Christmas Eve. These valves, the wells had to be capped because there was so much methane coming in, thousands of cubic meters a day. So it built up the pressure, and that pressure had to be released. I mean, the holes had to be capped, and the gas got in there, because otherwise, if you let it out in a calm day, it just may fill the entire valley floor, and then it take one spark and half the Longyearbyen may be gone. So every month or so, then the technician came up from the mainland, and then we just burned off the gas, and even though, I mean, the project produced scientifically solid knowledge that, well, we could geologically, it is feasible to do this CCS or carbon capture and storage project in Longyearbyen, but then sort of a couple of other non-scientific problems came out. One was that the Longyearbyen's power plant, which was producing 60 to 70,000 cubic meters, 60 to 70,000 tons of CO2 per year, is not nearly enough to justify this CO2 liquefying plant in Longyearbyen, because that needs large quantities. It's not cheap to liquefy CO2. And of course, this political decision to put down the coal mining and shift to renewables came a lot earlier than that was expected. So that kind of made this sort of a project in Longyearbyen obsolete. However, it did produce valuable data that can be applied elsewhere, and data and knowledge. And because it had many partners, it was like a seed for many other collaborations and offspins of that project. One of these, just one slide on this, is a Barents Sea source rocks and hydrocarbon seeps. And this is where we started to study the methane underground, because, well, we knew that there is a lot of methane, at least in places, but where it's coming from, how it's escaping, and this is kind of the project that Martin was talking about. And Martin was also part of this, or the postdoc at UNIS for 2 or 3 years, and well, there you see, that's the man. Fishing with a gas-charged sediments in a fjords, drilling from the sea ice, and this work is still ongoing up to today, because, I mean, these methanes and the significance of it, Martin was just talking about, so I'm not going to repeat that. And a couple of final slides. The renewable energy shift is actually happening in Longyearbyen, so it's the mines in Svea, which were the biggest coal mines, they were closed already 2015. As of last year, October, this local coal-fired power plant was closed down, so this is not producing anything anymore. Instead, we have now diesel generators and some battery storages for reserve. The local mine that is still producing about 100,000 tons of coal per year is going to be closed next summer, and they estimate it's going to take another year to dismantle the equipment and then return it back to the nature, basically. And yes, transitional phase is now on diesel, and then they are working on the new energy plan for Longyearbyen that would then be based on renewable energy. Transitional is based on diesel. It's a temporary solution, but, well, we all know there is nothing more permanent than a temporary solution, so we'll see how long that will take. But anyway, the new energy plan, the first draft is out. It includes different sources, wind, solar, geothermal, because of this CO2 project, we know what the temperature gradients are in the ground. It is possible to use the geothermal energy there. We have other problems there with, we don't want to melt the permafrost, because the entire town is built on permafrost. You start thawing the permafrost, all the buildings sort of collapse and stuff. So there are lots of technical problems. There are a couple of test sites. It is being tested out, these renewable energy. And there are lots of partners. I mean, local partners, Stora Norske, UNIS, this is where the know-how and technical expertise comes, but there are many more industry partners in this to develop these solutions. And it has large implications for not only Longyearbyen, but once we have these technologies and technological solutions in place, these could be applied in many places all across the Arctic. I mean, there are 4 million people living in the Arctic, and there are like hundreds, if not thousands, sort of such off-grid communities like Longyearbyen who have to produce their own energy and heat and electricity. So, and these solutions, most of these communities now live entirely on diesel. So these solutions are to be developed. This is all the innovation that we need, that Mario was also mentioning. So so this is, we live in interesting times. So it's and I think I shut up now, and I can take the questions over the lunch or in the evening. I don't think we have time for the. But that's how our field trips look like in a nice and bright day. Thank you very much.
Good afternoon. At first, I would like to say that this nice video is actually the greeting from Antarctica, or on the way to Antarctica, because one of the members of our Polar Club, Captain Janus Hannes, he can't be with us because he is on his ship on the way to Antarctica. But he likes to make photos, movies, and this is his greeting. So, now our subject is influences in polar research. No, influences are everywhere. It's so that can't be without okay. The polar regions have long captured the imagination of explorers, scientists, and policymakers alike. Today, we will dive into the fascinating intersections of history, science, and geopolitics that define these remote and rapidly changing areas of our planet. And this session is a celebration of the people, institutions, and ideas that have shaped polar research over the years, and those that continue to influence it today. And the subject in this block, they are very different, as the influences are very different. I will talk about the Estonian Polar Club, and because 40 years, you can imagine how many influences there have been. But I make a short introduction. Who are the others? So after me, there will be Dr. Fridtjof Melum, president of the Norwegian Polar Club. He will bring us tales of Arctic exploration with his talk on the Norwegian explorer Hans Henrik Hansen and his Arctic adventures. But you know, Mr. Hansen, maybe he had his adventures together with some people who came from here, with some Baltic Germans. Who knows? He will examine this subject. His extensive knowledge of polar history promises to offer us a wide picture of the challenges and triumphs of early Arctic explorers. Then we shall then pivot to the contemporary, as Professor Valur Ingimundarson discusses the Arctic and nation branding. A look how Arctic narratives are framed politically, particularly through the Arctic Circle Assembly. His insights into the interplay of geopolitics and national identity are sure to provoke thought. Then Rachel Gosnell will follow, providing a strategic perspective of the Arctic with her talk on the US strategic approach to the Arctic. It's sorry that she is not with us here in this room, but she will join via internet. Given the increasing focus on the region as a global crossroads, her military and academic expertise will shed light on the security dimensions of Arctic governance. To close the session, we shall explore how climate warming affects biotic interactions, aerosols, and sustainability of polar environments. Researchers like Anneli Poska, Hele Kiimann, Professors Heikki Juninen and Mikko Sipila will guide us through these critical and interconnected topics. The block is packed with rich insights, fascinating stories, and immortal reflection on how the past and present shape the future of polar research. But let us start now with the first presentation. So, some words about this mark. You have seen it everywhere. It's so that it's Estonian, very historical ship. It looks like a Viking ship, but it's not. It's similar. and where we sail in the middle of the oceans of the world. In the north is Arctic, in the south Antarctic. Why this shape? Because it's the first logo of Estonian Maritime Museum. Maritime Museum was established in 1935. And so we sail together with Maritime Museum. I honestly think we have not existed 40 years without such a good cooperation. So, the club was founded on the 1st of December 1984. Everything started because of the Antarctic exhibition. The first exhibition in Estonia that was done at all about Antarctic. And why we chose this date? Well, of course, it's the 1st of December, very important to all polar people, because the Antarctic Treaty was signed on the 1st of December, and everybody celebrates the Antarctic Day today. At least we celebrate not only Antarctic Day and our birthday of the club, and you all celebrate because of it we have the conference now. Yeah, then there are a lot of questions. Why museum? Polar researchers and by the museum. But why not? 40 years ago, there were discussions under which institute, under which university it will be good to start. But there are always some administrative, who knows, influences and troubles. By the museum, it was easiest at that time. And believe me, it's now also. Because you never know how the budgets of the institutes are, or what happens around. And so we joined the people with common interest in the Arctic and Antarctic. And mainly we are the researchers, polar researchers. But with us are a lot of others who have influenced the polar research, who have supported it in a very different ways. You can't imagine how rich is the variety of supporters. You can do it via art, or via a maritime trip, or lot of. So the founding of the club, it's the picture. Who were with us yesterday in the Fat Margaret Tower? Nowadays there is exposition. There are navigational instruments in this room. But 40 years ago, it was like a small cafe. And the first president, Jüri Martin, academician, who sends his best greetings, but he's too ill at the moment to be with us. And it's such a nice young boys from the 60s. Very famous people. Enkrem, Andres Tarand, famous penguin. At that time it was possible to get in closer contact with them. Enn Kaup, Rein Männik, Vello Park. So it's the first famous generation of Estonian polar researchers. Nowadays, you will hear later tomorrow already the son of Vello Park, Indrek Park. The objectives. So I very quickly, because give overview of what we are doing, where we are doing. So mainly we bring together the people who have participated in polar research. And we try to introduce and popularize the subject to the wider public. And also consult with polar issues. Whoever needs, some high officials or journalists or school people, children, And of course, we assist Maritime Museum in preserving the Estonian polar heritage, because during these years, there is the collection of photos, documents, items in Maritime Museum collections. Estonian polar heritage, but not only. It's so that nobody is alone there in the Arctic or Antarctic. Usually you are with somebody else, with some other countries, with other institutes. So it's valuable material. We are small. There are over 30 members and some foreign members in other countries with whom we have close relations. Most of the members have a background in research, and they have taken part in many expeditions, research trips, but new members are invited. Not simply so. They must have recommendations of 2 existing members. Now, the presidents of Polar Club have been Jüri Martin, Enn Kaup, Vello Park, Andres Tarand, and from this year, Andres Kollist. Some photos. It's 10 years ago. No, it's more than 10 years ago. This is 10 years ago. The Fat Margaret has changed around us. And as I mentioned, we have these polar collections. What are the biggest? Ships. You do not have time today to visit, but one of the most famous icebreakers in the world, the biggest, is icebreaker Suur Tõll, built in 1914. We are very proud to organize some of our events there. And then the other is former Coast Guard vessel, Valvas, built in USA. The first name was Bittersweet. It's also a nice place. There have been the event as it's built in USA. There was this, their embassy, together with their embassy we have had there. Nice meetings. And every year we celebrate our winter holidays there. They have very nice sauna. Don't believe that the sauna was built there in Alaska where the ship first worked. It's really so that the first thing that when Estonians get to the ship, what do they build there? Sauna. And still works well. Oh, and this is harbor where they are. We will all go today in this seaplane harbor to celebrate this conference. Now some activities. Oh, there are many. But not all are open to the public. Polar forums, polar evenings, once a month, but except the summer we have the meetings. And sometimes conferences, but never, ever we had such a big as now. So we are very happy that you are here. And we can do it together. Very important is popularization of polar research. Now you can work and measure this and that, but nobody knows about it. Or when it's only in a very special magazine. It's very valuable, but important is to show to the world, because the world needs us. Then celebration of important polar anniversaries, activities for the young people. About this I'll tell later. And networking, of course, with polar organizations, clubs, museums, embassies, whoever wants, with pleasure. One of the biggest events where our people participated, it was Expedition Antarctica 200. One of the most important persons who have organized it is also in this room, Maris Pruuli. But she has written a lot of books about it, but what I want to say is, okay, we wanted to celebrate the invention in Antarctica, but how to involve the whole world. We started with the ship and stopped in these harbors, in these museums, places where there are other important polar museums, polar institutes. For example, as in Oslo, and Norwegian Polar Club helped us, from museum helped us, United Kingdom, Cambridge, Scott Polar Research Institute, Bob is sitting also there, who helped a lot. So many seminars, so many meetings. Never in such a huge scale, geographically, politically, internationally. Very unique. And this is this famous ship, Admiral Bellingshausen, which did this trip. But another ship, polar ship, that just was in our harbor last summer, French polar research ship, Tara, very famous. All the polar ships are very welcome to our harbor. Okay. Different conferences, exhibitions, Arctic months. Very good partner is Ministry of Foreign Affairs. They love Arctic subjects, and we also. So it's a lot of possibilities to do nice things together. Big Estonian polar forums were when we celebrated 100 years of diplomatic relations between Norway and Estonia. It was 2 years ago. Then lot of activities. Now what I want to show, polar bear. We love polar bears. I know we love maybe more than people in Norway, because we celebrate every year International Polar Bear Day on the 27th of February, together with Tallinn Zoo, together with Estonian bears, with Estonian polar bears. Because what's good for the bear is good for the polar researcher or polar captain. The same important questions. Now about the young people. We organize polar quizzes. And who are successful, the winners have the possibilities to go to the expedition, to go to the real polar expedition together with the researchers, and to feel it, to enjoy it or hate it. And very popular has been, lot of participants all over Estonia, from all places. The first group was in 2017. One of these winners, actually in this room, she is already a polar researcher. Here she has the label, I want to be a polar researcher. Now the next group, 2019, and she studies in Tromsø University just now, and was in UNIS in Svalbard University also. And the last trip, we have cooperation with Finland, with Helsinki University, who has the research station in Kilpisjärvi. You know, it's a good place. It's such a place where borders of 3 countries meet. Norway, Sweden, Finland, a lot of possibilities to show more. And Norwegian Polar Institute has been a nice partner, has received us. Oh, and when I raised my eyes, I also met some people who are here on the picture. That if you like it, then you can't avoid it. You will continue. If not a polar researcher, then polar fan. And for fans and for friends, it's the final slide. Our books. This was in 1992. This was printed a week ago. Yeah, but now I have, as I have used to do, be responsible. Now I have You do not have time to ask questions, that's it. I have done it. And now I'm so happy that we have the friends, another club, Norwegian Polar Club. And we have here President of Norwegian Polar Club, Senior Scientist, Fridtjof Melum, please.
Thank you very much. First, I would like to send my congratulations to the Estonian Polar Club from the board of the Norwegian Polar Club for your anniversary. As you can see our logo here, we are a little older than you. We started out in 1933, and we have about 600 members. The club played probably a more important role in the first years than today, because now there are so many bodies that deals with the polar areas in Norway. So I'm going to tell a very strange story. Today, you know, in the polar history there has been many strange characters. And we know that most of them are very ambitious, and they are self-confident. Often they are exaggerating their own merits before they start, and they're not always quite truthful about what they are telling. And not all of them will become an Arctic or a polar hero. I thought I had 25 minutes. Sorry about that. Hans Henrik Hansen, he is one of those strange guys who is forgotten, and maybe it's a good reason for that. At least he was a very special guy. So, I found some interesting things about him, and I'll tell you now. In the newspapers in 1896, we could read that there was a skiing expedition going from Oslo, Norway, all the way through Arctic Siberia to the Bering Strait, over to Alaska and down to America, and he was going over to New York and take the steamer back to Oslo. He was going to use 3 years on this journey. He was 30 years old, and he didn't give any reason or purpose for the expedition. He said it was a secret. He was married, had one kid, and expected another one, so maybe he would like just to disappear. I don't know. He had a friend, a young student, who was an expert skier that would go with him, and they were supposed to go on skis, and then they would make a sledge from their skis when they came to Russia and Siberia, and then buy some dogs. And also on the way, they will follow the prisoners' transport to the gulags for some distance. There were fascinating stories about his background in the newspapers. And he was an explorer, and he was a sailor. That's true. He was a sportsman, a skier. He's run the Holmenkollen, which is quite famous in Norway. He was a speed skater. He was a long-distance runner. He has a Norwegian record in 10,000 meters and so on, which is quite exactly true. And he also had studied drawing in Munich. And so some of the stuff he would like to do during the journey was to look at and to map some of the unexplored areas and make maps of that. the river deltas and so on. He has been a mercenary during the civil war in Argentina. We don't know what civil war that was. It's difficult to track. He has participated in all kinds of expeditions in South America and Southeast Asia and Africa. He has met Stanley and all kinds of things. Some of it might be a little bit true, but most of it is not easy to confirm. He has been at sea for 2 years, and he participated in a boat race in America's Cup, which is probably true. He sailed a Viking ship from Norway to the World Exhibition in Chicago. The newspaper said even that he was the captain on board, and it's not true. Maybe he was on the last leg because they had to row the boat, the Viking ship, from New York and up to the lakes before they went to Chicago. And there's one space there where he could have been, so yeah. And he was fluent in 8 languages. So that's just some of his background. And he was ridiculed in the newspapers. People thought he was kind of weird, and he even distanced himself from Baron von Münchhausen in many respects. So they didn't believe in the stories, and at least they must have been, way over. And he was extremely self-confident, and he was also a likable guy, and talked and entertained people. Anyway, here you can see a picture of him. That's a little later. I'll come back to that later. So he started out from Oslo, end of January in 1896. He went up to Trondheim. It took 2 weeks, and there was very little snow and rain, so he had to carry the skis on his back and use a horse and also some train. And he stopped in Trondheim, and then his friend left him. He wouldn't go further. He stopped there for a week or so, and he took the train over to the border of Sweden. And when he came to Storlien, he just canceled the whole thing because there was not enough snow. Well, then suddenly the weather changed, so he changed his mind. And apparently he managed to get through Sweden, and he fell down from a cliff and broke his skis and also injured his foot. But anyway, he got some new skis, and you can see here he didn't come up to the polar circle. And he managed to cross over to Finland at Kvarken, and ended up in Vasa, where you see number 27 there. That's actually what I just said. So he spent like 3 months to get to Vasa. But when he came there, he changed his mind, and he met first he planned to stay over summer because it was too late, and then he would learn Russian because that could be useful. And he could do that in 1 month or so. It's no problem. But he met a guy called John Edward Moe in Vasa, who was a capitalist there, and he was willing to sponsor Hansen to go to the New Siberian Islands and look for signs of Fridtjof Nansen, because he's been away for 3 years, and nobody ever heard from him. And Baron Edvard von Toll, as the Estonian, he had put out some depots for Nansen up there at the New Siberian Islands, and so it would be good to go there and see if Nansen has been at those depots. And Hansen would like to do this and bring news to the Norwegian people about the fate of the Fram exhibition. And then there was another thing, and that was André, the balloon expedition. It was planned for 1896, And people were afraid that if they landed somewhere in Siberia, they would get killed by the local people because there was something strange coming from above. And so they actually made some leaflets like this that they distributed up there. And Hansen was supposed to take this with him and give them to local people, which actually said that if you see something coming from the air with a basket, just help them to get landed, and take good care of them and give them and send them to the governments, because the Tsar has already given them their blessing and so on. So in the end, the weather was not good enough in 1896, so they postponed the expedition. But the year after, of course, André, he left Spitsbergen and was lost in the Arctic Ocean. So he was here. He went to St. Petersburg, and he was going all the way up here to the New Siberian Islands. He would like to go up along the Lena River and then go with some of these mammoth tusk hunters and join them up to the Siberian Islands. So anyway, he went to Russia, and he met Baron von Thal in St. Petersburg, and he got some advice, and he got introductory letters. And he took the railway to Irkutsk to see the polar expert Sibriakov. I don't know if he met him. But again, he was too late. So we had to cancel the plans. He could not go on the rivers. And then also Nansen appeared during the summer of 96, so there was no reason to look for him. So then he joined a scientific expedition to one of the side rivers of Lena, called Adlan River. So what about the André exhibitions? He claimed in the newspapers that he had been looking for André for 2 years in Siberia on expeditions and hired by the Swedish government. Well, Hansen, he stayed in Siberia for some time, and he got a job for surveying and prospecting based in Tomsk. There was an expedition to Siberia looking for André, a Swedish one, led by a newspaper man called Stadling. They didn't find any traces of him, and they didn't mention anything about Hansen either. But then a year later, there were some new rumors about André. Somebody has seen the basket and 3 dead bodies. And another guy, Fredrik Martin, he got some money to go and look for him. And actually, Hansen was hired to this expedition, which only lasted 2 weeks because it was false and it was a hoax. So this is probably the only 2 weeks he was engaged officially in looking for André. So they were actually looking in this area here, which is quite far from Spitsbergen. So it's not very unlikely that it would be here, actually. So the next thing about Hansen that we hear about is in 1908. Hansen at this time also have some interest in Tbilisi in Georgia. He owns a tin mine there, and he also owns some gold mines in Siberia, according to himself. He hears about this race going from New York all the way through America and Siberia and back to Paris. And he would like to join that. So he goes to Paris and he talks about all these experiences and all these connections. And he was actually accepted to be on a French car. First he was rejected because you're supposed to bring your own car. But Hansen, he couldn't even drive a car. And the route was actually then from New York, crossing America, ship to Alaska, crossing with the Bering Strait, and all the way to Lena and down to Irkutsk and Moscow and so on. He had a lot of ideas how to deal with this. He mentioned you had tailwind most of the time there up in northeastern Siberia, so you could put some skis on the car and you can have a sail, and so it would be very easy to get through there. Yeah. And he had lots of good ideas. And here you can see the start in New York. Hansen is actually this guy here with the uniform, and this is the French car. And there were 6 cars that started from New York. Here is the charming Hansen, this guy here. He likes to wear a captain's uniform. He told that he got it from the Argentinian Navy. Well, probably not. He was very popular among the women along the route, and everybody was gathering around him because he could speak in all kinds of languages. Yeah, so that's him. I won't go into the details about this race, but it was a very eventful race. And Hansen, he got fed up with the French. They argued, so he changed and he got a seat in the American car. And they went up to Alaska by boat from Seattle, and it turned out that it was impossible to navigate the Yukon River, and it was too late. So they changed the plans. They shifted over to Vladivostok, and we're going through Siberia, mostly along the new railway line. And yeah, eventually the 3 cars came back to Paris. And Hansen, he was very useful on this trip because he was strong and he was not afraid to work. This winter, when they were crossing America, it was a really bad winter with lots of snowstorm, and so they spent several months extra time than planned. Okay, so after the race, Hansen, he disappeared, and newspapers told that he was missing. But in 1911, he turned up as a manager of an ice skating rink in St. Petersburg. And here you can see the opening. I tried to translate some of it, but and this is true. His name is there. And then he disappeared again, and in 1919 he died of syphilis and liver disease. So that's the story about Hans Henrik Hansen, and he's not one of those polar heroes that survived. So I think I have time for a question or two.
Did he ever go back to his wife or not?
He did not go back to Norway at all. And when his mother saw in newspapers in 1908 that he was on this race, she took contact with the foreign ministry and tried to get in contact with his son. He had married a Russian woman in Siberia and had a daughter there also. Yeah. But he never came back to Norway.
Yeah, Kadri Tamm from Tallinn Technical University, from Department of Energy Technology. So I have a question. What were the main tools what you recommend, how he survived? What was the main tools?
Well, first of all, he was very good to persuade people about his background, his abilities, and which you come a long way with that, actually, if you can persuade people to believe you. I didn't have time to talk about all the equipment that he brought for this trip to Siberia. He had a revolver. He had killed 5 tigers with that in Asia. He had a special rifle or shotgun that he had constructed himself and get made in America. He had a special lamp he got from Edison to lighten the fire somehow. I don't know how it worked. So he has all kinds of things with him. But it's a long story. I've written a big article about it. And yeah, I'm over time. But 2 years later, you could read in the newspapers that there was another Norwegian who would like to go skiing across the same route. And this was, well, yeah, it was something that he said that if he managed to do the tour without no money at all, he was only going to give lecture and things along the route, he would win an award of $1 million from somebody in America. And he came also to Finland, come to Helsinki. And then people didn't believe his story, so they tried to check the background with these banks where all these things were, and it turned out it was fake, and we haven't heard about him since. Okay, thank you.
Okay, my name is Valur Ingimundarson, and I'm a professor of contemporary history at the University of Iceland. And I'm going to talk here about the Arctic Circle Assembly, which was initiated by former Icelandic President Ólafur Ragnar Grímsson, which is held annually in Reykjavik, has become the biggest annual conference venue on the Arctic. It's a personal legacy and nation branding project with the aim of drawing attention to Iceland's location in the north. And in this talk, I will talk about the rationale behind it, its development and reception. And it has been given much outside political attention from the start. And it was a testament to Grímsson's success in framing the project, embellished governance ambitions, and using his presidential position to promote it before he left the office, and in portraying himself as a sort of a global Arctic ambassador and salesman. But as I stress, external geopolitical interpretations of the project have sometimes been exaggerated or wrong, and as a nation branding project, it has created confusion about Iceland's Arctic policies. Iceland's prioritization of the Arctic and its foreign policy is a recent phenomenon. What prompted it were 2 seminal events: the US military withdrawal from Iceland. Actually, they are back more or less since 2016, but at that time it was a major break, relegating temporarily into history one of the Cold War's main theaters in the north. And the second reason was the collapse of the Icelandic banking system during the 2008 financial crisis. The Arctic turn reflected a discursive strategy to compensate geopolitically and economically for the loss of Iceland's military importance in a post-Cold War setting, and to offer a vision based on the Arctic's future potential, economic particularly, following the national trauma caused by the financial crash. The 2013 launching of the Arctic Circle Assembly Conference by Grímsson at the National Press Club in Washington, D.C., fitted into Iceland's efforts to promote an Arctic political agenda driven by status-seeking in search for social recognition abroad, to cement a material success story after the 2008 financial shock. Even if it was not a government-sponsored project, the Arctic Circle quickly became part of Iceland's nation branding. The conference takes place at the Harpa Conference Hall, which is situated by Reykjavik's harbour, which has a loaded symbolic meaning of its own. It is inextricably tied to the ill-fated banking expansion of the mid-2000s, when a leading Icelandic businessman, who later became bankrupt, spearheaded the construction project. Having started at the beginning of 2007, the work on Harpa was immediately halted after the 2008 financial collapse. For many, it became a testimony to the follies and excesses of that period, with suggestions made that it should be kept permanently in its half-finished state in commemoration of a dark chapter in Iceland's history. After it was decided to finish the building, Harpa assumed yet another function following its inauguration in 2011 as a source of national pride, a modern monument of Iceland's expedite and successful reconstruction efforts. Thus, it became the perfect site and vehicle for a status-seeking project such as the Arctic Circle Assembly. Grímsson claimed that he wanted to strengthen the policy-making process in the Arctic by bringing a wide range of stakeholders under one large tent, as he put it. What he had in mind was an annual conference representing social as well as geographic inclusivity, with the participation of government representatives, political leaders, business people, scientists, activists, indigenous peoples from the Arctic countries, as well as non-Arctic ones from Asia, Europe, and other parts of the world. The Arctic Circle Assembly was a project that he and his collaborators, such as U.S. publishing executive Alice Rogoff, had been working on for some time prior to announcing it. And Grímsson argued that the profound, as he put it, new significance of the Arctic in global terms had required a new platform on the scale of the World Economic Forum in Davos, with political leaders attending, or a medieval square where anyone could come, knowing that they meet everybody and everybody there. The project also had has a secretariat, and to add luster to it, the word assembly was affixed to its name. What this suggested was that it had something to do with an international institution, which was not the case. In addition, the reference to Davos as a symbolic site for the rich and powerful fitted uneasily with the inclusive rhetoric used to promote the undertaking, or with the elevation of democratic and bottom-up approaches. But Grímsson has sought to mediate these paradoxical impulses at the annual Arctic Circle conferences by mixing elite panel sessions, where he is often the master of ceremony, with open academic ones, without external interference, where scholars and researchers from universities and research institutes have presented their findings. The Arctic Circle Assembly immediately prompted conspiratorial speculations and suspicions abroad. It was claimed that it was meant to assume a specific political role outside the formal cooperation of the Arctic states, or the Arctic 8, especially those applying for admission to the Arctic Councils as observers. It was projected as representing a challenge to the Arctic Council because of its governance aspirations and its open door policy vis-à-vis non-Arctic states. At the National Press Club, when he announced the establishment of this project, Grímsson had in fact praised the Arctic Council as an extraordinarily successful instrument for Arctic cooperation. Still, since it was controlled by the Arctic 8 states, he suggested that it lacked inclusiveness and that decisions had to be made on how it should move forward. More specifically, he offered the Arctic Circle Assembly as a platform for those who were not allowed to speak at the Arctic Council, such as the observers. The Norwegian government was not happy with the launching of the Arctic Circle Assembly, seeing it as a competitor to the Arctic Frontiers Conference in Tromsø, which has been held annually since 2007, and which has also attracted politicians, business people, academics, and representatives from local Arctic communities. The Arctic Circle initiative also flew in the face of Norway's idea behind the Arctic Frontiers, which was about protecting the Arctic governing structures led by the Arctic 8. As Norway's Foreign Minister Espen Barth Eide put it, we are happy that more people want to join our club, that is the Arctic Council as observers, because this means they are not starting another club. And that gives some influence on what topics are discussed in relation to the Arctic. Moreover, Jonas Gahr Støre, an opposition leader, a Labour leader, and the current Prime Minister of Norway stated on the occasion of the 10-year anniversary of Norway's High North strategy that he feared that Norway could lose its initiative on the Arctic, referring specifically to the presence of French President François Hollande, that was in 2015, at the Arctic Circle Assembly. In contrast to its Norwegian counterpart, which plays an instrumental role in formulating the program of the Arctic Frontiers and in inviting high-level participants, the Icelandic Foreign Ministry assumed no such function with respect to the Arctic Circle conferences, where Grímsson is in the leading role. His inclusive description of the Arctic Circle Assembly prompted some Arctic scholars to compare the gathering to a bazaar, where the exchange of global and marginalized knowledge, ideas, and interests could influence Arctic governance. What they termed bazaar governance was about market power exercised through informal dealings, networks, and hierarchies. They did not argue that the Arctic Circle was competing with the Arctic Council for the right to govern Arctic affairs. Still, in a rather alarmist fashion, this is from the Arctic Council, they interpreted the timing of Grímsson's initiative as a provocation to the Arctic Council before a ministerial meeting where decision was made on the application by Asian states, China, Japan, South Korea, Singapore, and India, and the EU Commission for an observer status. They also suggested that the Arctic circles could reposition Iceland geopolitically as a gateway for such non-conformist global Arctic perspectives. The establishment of the Arctic Council, Arctic Circle Assembly had nothing to do with the applications of non-Arctic states or the EU, or with pressuring the Arctic Council. Grímsson had revived an old idea stemming from the Reagan-Gorbachev summit in Reykjavik in 1986, in the waning years of the Cold War, of highlighting Iceland's geostrategic location for branding purposes. But he was not acting on behalf of the Icelandic government or promoting its Arctic policies. He rationalized the selection of Iceland as the host of the Arctic Circle Conference by saying that after being ignored by much of the world, it had been put on the global map due to global warming. Such exceptionalist rhetoric made little sense, given that other places were far more affected by climate change. But some scholars theorized that there was a Chinese connection here, that Grímsson's project launch had coincided with the signing of the free trade agreement between Iceland and China, and that it was linked to the teaming up of an Icelandic firm with a Chinese company in the Arctic for oil exploration. Further, it was argued that the involvement of Alaskan and Greenlandic partners in the Arctic Circle Conference betrayed a sub-state political agenda with autonomous Arctic oases that did not necessarily echo those of the US or the Danish governments. Another commentator went much further, seeing the Arctic Circle, I quote, as a geopolitical interest of Grímsson's in connecting subnational governments and non-Arctic states to the Arctic in a way that at some point has the potential to displace the Arctic Council and national Arctic sovereignty. Yet another one, yet another one made the outlandish point that the Arctic Circle, with a logo of having 6 people holding hands, was a reaction to the exclusion of Iceland from the venue of the Arctic 5 Arctic coastal states, making claim in the Arctic, Central Arctic Ocean. Thus, Grímsson initiative was portrayed as a major geopolitical intervention aimed at making a direct stakeholding claim in Arctic governments, by promoting the interests of non-Arctic states, at catapulting Iceland to a central global role in Arctic affairs, as well as highlighting its interests in the region through its blossoming relationship with China, and a furthering of a para-state agenda by creating a network of the marginalized, with transcended sovereign interests of states in a potentially destructive way. Such all-embracing and highly loaded political interpretation certainly gave the initiative the weight and mystic aura its founder sought in the first place. In terms of status-seeking, Arctic Circle became a major brand name, which the Icelandic government exploited, but whose role has always been that of a second fiddle. Most of these accounts were highly speculative, overblown, or plainly wrong. There was no validity to suggestions that state interests, such as those of China and Russia, were behind the Arctic Circle or among its financial sponsors, or that a link existed between it and Iceland's Arctic policy, such as its claim, which is now abandoned, to be seen as an Arctic coastal state. While Grímsson praised China's Arctic policy as being constructive, the launch of the Arctic Circle conference was totally unrelated to Iceland's signing of the trade deal with China, or the conclusion of an agreement with a Chinese company for oil exploration, or other Arctic policy declarations or actions. When embarking on the initiative, Grímsson insisted on viewing the Arctic in global terms, rather than regional ones, where the Arctic states were in charge. There was a need, he claimed, for involving non-Arctic states, including China, India, Nepal, and Pakistan, that were influenced by changes in the Arctic, such as melting of the sea ice and the Greenland glaciers, as well as in Antarctica, and in the region identified with the third pole, the Himalayas, the ice-covered parts of Asia. Thus, the Arctic Circle Assembly was projected as a venue where the representatives of the Arctic Council observer states, as well as states with no such status, could, as I pointed out, meet on an equal basis. And also where regional sub-state interests and perspectives, such as those of Greenland, Alaska, and Scotland, could be addressed. An argument could certainly be made for transcending a self-serving hegemonial regional framework established by the Arctic 8, on the grounds that the effects of climate change did not respect sovereign spaces. Yet such a catch-all approach could also reproduce uncritical tendencies in climate change narratives not to assign specific responsibility or single-out culprits for global warming. Iceland's official Arctic policy has from the start been far more restrictive than Grímsson's vision, with its emphasis on the UN Convention of the Law of the Sea, UNCLOS, and Arctic Council, run by the Arctic 8, as cornerstones of Arctic governance. It was not consistent with Grímsson's argument that the Arctic Circle Assembly was within the framework of Arctic governance, or proof of a reasonable alternative model to somewhat broken intergovernmental model, as he put it. Grímsson's philosophy reflected the idealization of Arctic exceptionalism, where geopolitical divisions rooted in an East-West dichotomy had been relegated to a Cold War past. He had been highly critical of the initial refusal of Western states to come to Iceland's rescue when its banking system collapsed, and he had also backed efforts to expand Iceland's ties with China following the financial crisis. In addition, he had publicly opposed Iceland's membership in the European Union, even after the Icelandic government started negotiations with it on joining the organization in 2009, which was later put on hold. Hence, his political views sometimes clashed with government policies, which could lead to confusion and misunderstanding abroad. With the Icelandic president having no formal constitutional policy-making role, if a bully, a pulpit one, the office holder can in fact only exert institutional power in limited circumstances. Consistent with his Arctic cooperative philosophy, Grímsson refrained from voicing criticism of Russia's foreign and Arctic policies. He made the point that the Arctic Council was the only post-Cold War forum for a great power dialogue, and it was important that the Arctic would not be divided up. When Russia invaded Ukraine in 2022, he did not blame Russia. Instead, he seemed to shift the blame on Western policy since the end of the Cold War, which he claimed had not succeeded in guaranteeing stability or peace in Europe. Yet, while stressing that there would be no winner in the war, he also sympathized with the flight of the Ukrainians and of the millions of refugees, lamenting the destruction of Ukraine's infrastructure. It's ambiguous comments, however, met with social media criticism in Iceland on the grounds that he was aligning with the aggressor, a charge that he denied. Despite its pro-Ukrainian, despite its very strong pro-Ukrainian stance, the Icelandic political elite remained silent on the former president's intervention. Foreign Minister Þórdís Kolbrún Reykfjörð Gylfadóttir used, however, the opportunity at the Arctic Circle Assembly to criticize Russia in vocal terms, so using his venue to do it. Beate Steinweg has argued that the Arctic Circle Assembly represents a new soft law dimension of Arctic governance, and that it's part of a regime complex operating in the intersection between sovereign states and formalized cooperative arrangements. Grímsson has echoed such a view by contending that the Arctic Circle Conference has added 3 components to the Arctic governance structure, by offering governments an international platform to present their views and politics, by giving subnational and regional entities a chance to advance their interests and perspectives independently of their central governments, and by bringing attention to Arctic dialogues and cooperation outside the region, which has contributed to making non-Arctic states and entities constructive partners. As a global brand, the Arctic Circle Assembly in Reykjavik and its spin-off forums in other cities have certainly become visible meeting places for government delegations, business interests, NGOs, indigenous peoples, and academia. But as a high-profile venue for information sharing and networking, it should not be conflated with Arctic governance. And the periodic global attention on the Arctic has not focused on state-managed state promotions at the Arctic Circle Conference, but on concrete policy announcement or actions, such as the Ilulissat Declaration on Arctic Cooperation or the Russian flag planting exercise in 2007 on the North Pole, and territorial claims based on UNCLOS. So to sum up, one of the things that have disadvantageously affected this forum is that it has created the false impression that Grímsson was responsible for Iceland's Arctic policies and its main enforcer. What partly explains is that no attempt was made to resolve or negotiate the contradiction between Grímsson's inclusive vision of the global Arctic and the Icelandic government's more exclusive regional one. Thus, one can detect tensions in Iceland's Arctic status-seeking efforts, where the public and private mix, where the embellished small state ambitions override a coherent policy presentation, and the philosophy of the Arctic Circle Assembly is not based on Iceland's foreign and Arctic policies or dictated by the interests of other states, but it reflects an agenda projected and articulated, as I have said here, by its founder. It is at bottom, a personal legacy project which has morphed into nation branding, targeting international audiences, where Grímsson reigns supreme under the approving eyes or gaze of Icelandic domestic elites. Thank you.
Rachel, I hope you are still there. We all wish Thanksgiving Day to America, and now we would like to hear about the strategy to Arctic, please.
First, thank you for that. I wish I could be in Estonia. It's a wonderful place, and I really do want to congratulate you first, of course, on the anniversary of the Polar impactful conference. I think it's really important that we have these discussions, and I do want to congratulate you on the breadth of speakers you've brought in. I've been listening, and I think it's very important to bring together diverse groups of experts so that we can better understand each aspect of the Arctic in order to have a more comprehensive overview. And I think that really aligns with how the US, frankly, is approaching the Arctic region. The Arctic region, as you all know, is at the intersection of a number of different converging and sometimes diverging trends. Climate in particular is driving a lot of the interest, but the science aspect is so critically important and underpins all of our Arctic knowledge as we look for economic opportunities, as we look at geopolitical impacts, and as we look at, frankly, at the security of the region, and to enable some cooperative forums. I appreciate the last brief on the Arctic Council. I enjoyed presenting there last month. It is a wonderful opportunity to have these discussions. So with that, I'd like to go ahead and begin talking about the US strategic approach to the Arctic and understanding what that means. So I'm trying to click through to the next slide here. It looks like I might have there we go. So looking at why the Arctic matters to the US, but more broadly to not just regional security, but I think global security now. Again, the Arctic has become one mere piece of the global chessboard, and we have to understand from the American perspective, first and foremost, the United States is an Arctic nation. We have been since 1867, and that homeland defense piece is critically important for the American approach to the Arctic. But I think we also need to recognize with the accession of Sweden and Finland into the North Atlantic Treaty Organization, we now see an increasingly important northern flank of NATO. And that northern flank is now converged with the eastern flank through Finland. And so we need to re-examine our approach to the North Atlantic Treaty Organization and what the implications are of a warming Arctic for our collective defense, our collective security. From the American perspective, obviously looking at the other side of the Arctic, the Bering Strait, Alaska, and the importance of that region to the execution of operations in the Indo-Pacific region really is increasingly important. And it's an area probably not as well understood or as well examined as, of course, the European high north, which tends to be the most heavily populated, the most heavily economically developed, and the most heavily militarized part of the Arctic. Bringing back to the European high north, though, I think when we look at the North American approaches, those sea lines of communications, we have to recognize the critical role of the Arctic for both the GI, so the Greenland, Iceland, United Kingdom, and Norway gap, but also for the Bering Strait. And so when we're looking at the comprehensive American approach, all of these elements really highlight our national interests and our interests moving forward into this rather complicated part of the world. And I think it's important to understand that when we look at, let's see, if we can go to the next slide. I think I've clicked too many slides here. Okay, we'll move to the next. Excellent. Look at some tech support. But when we look at the Arctic, and we have to understand that the Arctic is undergoing a dramatic transformation, and that climate change is really critical to that transformation. And so underpinning this transformation is really our strategic guidance. We had a new national strategy for the Arctic region that was released in October 2022, just in time to roll out actually at that year's Arctic Circle Assembly. And climate change is the key driver. But obviously, there's been a lot of geopolitical change since the 2013 national strategy came out. And so it was an opportunity to reflect upon the geopolitical changes that we have seen in the world and to present the Arctic as this emerging arena of strategic competition. And I think when you look at the Defense Department strategy that came out in July of this year, you can really see that strategic landscape being updated to reflect the realities of the Arctic region and the regional as well as global players that are increasingly making an impact. Both for positive, I would say, in terms of the science realm, but also in the competition arena and referring directly to nations like Russia and China. But I think it's important to highlight that underpinning both of these strategies is a United States that seeks an Arctic region that is peaceful, stable, prosperous, and cooperative. But I think it has more of a realistic reflection upon the need to both protect and advance our national interests and work together with our allies and partners to confront the challenges that are emerging in this really unique and incredibly important part of the world. We'll go to the next slide. I don't seem to be able to click. There we go. Excellent. So when we talk about the Arctic, I think it's important to highlight that this is a very unique part of the world. And as a Navy strategist, as well as an academic, I'm a PhD candidate focused on Arctic security and U.S. Arctic strategy. I think it's important to recognize that operating in the Arctic is unlike any other part of the world in that your first task is survival. And that is challenging. And so when you look at the challenges from the security side, understanding the weather and the climate and being able to survive are incredibly important. And that is where the need to improve our scientific research or scientific understanding of the region so that we can better model climate, but also understand weather and have a better prediction of weather is very, very important. I would say deterrence and defense are much more important and much more relevant to the Arctic today than 10, 20 years ago when we first started looking at this region from a national perspective with a greater understanding and a greater eye to the north. There are a significant amount of challenges, and I'm happy to get to any of these in the Q&A, but I'll touch on them briefly. The Arctic is a very challenging place to operate and to have economic prosperity in because of the lack of infrastructure, the remoteness of it, the extreme weather conditions, and the evolving climate, which we're still trying to better understand. A lot of different organizations are using the science that is being collected by the researchers in Estonia and across the world to help understand what we need to do to improve our capability to operate and to respond to crises in the region. But it's certainly not an easy thing, and it does require that we work together to be able to have this improved understanding, as well as the improved economic investment to be able to improve our infrastructure. Economic security remains challenging in the region. We're seeing an abundance of economic resources, not just oil and gas, but of course, rare earth elements that are so critical to sustaining the green transition and green energy, but also critical to sustaining military operations. And we have to recognize that the region will be increasingly important for resource extraction in the future. And yet that's at a little bit of an odds with the need to ensure environmental regulations and protections because it is such a fragile ecosystem. And we have a lot of indigenous communities that rely upon their traditional ways to sustain their lifestyles. And so looking at how does climate change affect that, as well as how does this increasing economic interest impact the entire ecosystem within the region. Go to the next slide, please. Looking next at what is happening in terms of the militarization of the region, I think is incredibly important as you look at how the United States is approaching the region. But not just the United States. I think a number of nations have started to become wary of Russia's Arctic buildup. We can talk extensively in the question and answer period, but I think this map from a US senator really highlights that Russia is seeking to exploit the natural resources in the region, which those on its sovereign territory, certainly it's entitled to do under the international law and norms, but it has put a significant amount of investment in militarizing the region, developing significant capabilities, both under the sea with their submarines, as well as surface, air, and the land domain. And we'll go to the next slide, please. So I think another relative newcomer to the Arctic region is China. Now, China will trace, of course, their Arctic lineage back to the signing of the Spitsbergen, now Svalbard Treaty back in 1925. It was a different Chinese government that signed that, but China has been very active in investing across the Arctic and the northern region, and conducting a number of different patrols with their icebreakers. They now have 3, and they are doing a lot of scientific research that is certainly dual use, which will enable them to have commercial and military operations in the region into the future. And I think that should give a number of us a bit of a pause, particularly given behaviors elsewhere. But their categorization of themselves in their 2018 Arctic White Paper, I think, demonstrates a vested interest in developing the economic opportunities and perhaps the northern route, maritime routes as well. But I think it's important to recognize that China is not an Arctic nation, and so we want to be inclusive, certainly, of scientific research, but wary of their intentions in the region, particularly as we see strategic competition really taking hold. And that's, I think, very well highlighted in the U.S. Arctic strategies. We'll go to the next slide. Thank you. And you can see there's a lot of Chinese investment in the region. Oh, we'll go back one slide. Thank you. That includes, of course, Svalbard opening up their Yellow River Research Station in the early 2000s, but also mentioning some of the Arctic investment across the region. Iceland, I think, was just mentioned in the last presentation, but China has significantly invested in every Arctic state. I think now you see an increased investment in the Russian Arctic, particularly looking at the extraction and development of the liquefied natural gas. China has increasingly filled the void that has been left behind when Western nations have left investment in technological development of those resources because of the sanctions stemming from the Ukraine conflict. And I think you'll continue to see China really pushing to get that foothold in the Arctic by investing in and providing technology for Russia, which perhaps is concerning for all of us, perhaps most Russia. But I think there is some strategic mistrust, but we need to be examining what that closer relationship between Russia and China truly means for the broader circumpolar Arctic region. Oop. Let's see, I think my clicking is going the wrong way, so I'll just let you click. If you can go to the next slide, please. Thank you. And now when we look at the ice curtain emerging, as it's been called, and I think we've seen this name different things, there's been some question as to whether there's an axis of upheaval or an axis of adversaries kind of emerging in the Arctic region. And I was actually at an event in Anchorage last week discussing this. And there's a question as to whether we do have an ice curtain emerging. And you can see by this graphic that the NATO Arctic, 7 out of the 8 Arctic nations are now unified within the alliance. So about half of the Arctic, Russia is still about 53% of the Arctic coastline. There's a question as to whether there is an ice curtain emerging, but I think everybody is generally in agreement that this era of Arctic exceptionalism has ended, and we are seeing a new arena of strategic competition. And so when we look at the future, we have to understand in terms of developing our strategic approaches that this is our new strategic landscape. And while it doesn't mean a reemergence of a Cold War, we do have to look at how we're evolving our approach to deterrence and defense of this region. It is a region that requires significant capabilities, significant skill sets, and is not as simple as just taking any assets that you have anywhere around the globe and sending them north and expecting them to be successful. So when we're looking at our strategic approach, certainly that is factoring in to how we are evaluating the region. So how do we advance U.S. interests? And I think that the national strategy really looks at some primary pillars. First and foremost, the importance of security and deterring any threats to the homeland, but also collective defense, collective securities with our allies. And we need to also understand the importance of climate change and environmental protection, because really climate change, that climate security nexus, is incredibly important in this part of the world. It underpins how we approach security in the Arctic. Understanding the effects of permafrost thaw and coastal erosion on our defense infrastructure is critically important, and we are working very hard to improving that because it underpins our infrastructure to support military operations and exercises in the region. We're also looking at how do we pursue sustainable economic development. And again, I think it's so critically important that we are working with our allies and partners to share data, share investments, and ensure sustainable development across the region. When we look at cooperation across the region, I think that underpins our US approach. Oh, I think I clicked on the wrong side again. Let's see, there we go. That really brings us to our national principles, which are looking at deepening our relationships and planning for those investments, but really basing upon a whole of government approach to this Arctic strategy. And so I want to highlight our new Defense Department strategy too, because I think it really echoes that national approach, particularly with enhancing our capabilities. But I think most importantly for this audience is that ability to, and necessity to engage with our allies and partners. And I would say our Defense Department approach is more collaborative than it has ever been when looking at the Arctic, because there is a recognition that this is a very challenging area to operate in. And we have to work together to be successful, but to also demonstrate the shared resolution and resolve to commitment to our collective defense in the Arctic region. Arctic operations are challenging. We highlighted this, but really the science plays such a critically important part to all of these challenges. And I want to underscore that the need to solve these challenges on both the scientific as well as the defense side of things. Looking at the weather, the communications, we all understand the challenges posed by the ionospheric conditions, but how do we resolve those? And I think that the scientific research really will continue to play a large part. And then understanding domain awareness and where we are with that and how we can improve that based upon some of the limitations that we're faced in that region. So looking at the Arctic in general, and I hope to really convey that the American approach is really that the Arctic is at this intersection of a number of key trends that often converge or diverge in the Arctic, looking at the climate, the economic, geopolitical, and security trends. Each subregion is very different in how it is populated, economically developed, or frankly, even scientifically understood. The European High North plays such a critical role in all of this. And the United States is certainly aware of that in looking at the European High North and that really the NATO's really front yard as being so important to the trends of the Arctic. We're looking at the rise of strategic competition, and understanding what different players and actors are doing, I think, is very important to understanding our collective approach within the alliance, but within like-minded nations. And really, NATO is continuing to work together, and the US is very much supportive of that as we get to know, working with our allies and partners and approaching this region collectively so that we can better deter and defend this critically important part of the world. And so with that, I think I'm just about out of time, but certainly happy to answer any questions that you may have. And again, I'd like to congratulate the organizers for bringing together so many diverse perspectives so that we can have these critical discussions and understanding of how all of the Arctic pieces work together in this really emerging arena of strategic competition and really pivotal part of our defense posture in the United States. Thank you.
Thank you, Rachel, but unfortunately we do not have time for questions. So now I would like to invite here Anneli Poska.
Can you hear me? As said, I am Anneli Poska, coming from here, from Tallinn, University of Technology, and my co-author of this talk is Annika Saarto, coming from Finland, University of Turku. And now I will open then the mixed bag of research talks of this afternoon and take you back practically to the beginning of this morning when we heard two talks about climate change and biota, or the plants. And starting from preparing this talk, I started to the question which probably most of researchers here have had once or twice in their life. So why Arctic and what it has to do with your home? It is easy to answer for Annika, because everyone here probably knows where Santa Claus lives, so it is easy to guess. Estonia is a little bit more complicated. We got already nice explanations this morning. When I was thinking about that, actually, two words popped in my mind: environment and change. That's probably not understandable for everyone, but coming from my profession as paleoecologist, it makes sense. So the landscapes we observe and the climates we observe right now in Arctic, northern Scandinavia, or in Svalbard, for example, this is something what Estonia experienced a long time ago, around 14,000 years ago, after the end of last glaciation. We had probably exactly the same plants and most probably also lots of the same animals going around. Now, just to refresh your memory, this is a long time perspective of kind of geological world. And as you see, we are actually living in a very exceptional period of warmth, when often we hear from journalists talking about greenhouse and greenhouse effects and so on. Actually, Quaternary era in geology is ice house. So we have these long periods of rather cold climates and then rather short periods of warm climates. And right now, at the end there, we are hitting one of these. And what it does for ecosystem, it forces it to move. It is like a running marathon in principle, because anytime it gets really warm, all the cold-tolerant species have to find their niche somewhere else. And sometimes it can happen like thousands of kilometers away. And these repeated cycles here have actually lost lots of species because of that they couldn't run anymore, or they didn't reach their habitat enough quickly. Now, other thing what probably everyone has heard in this room is this hockey stick model, what we experience now. Our present climate change looks something like that. We had quite a long cooling from middle Holocene optimum, or the kind of warmest time latest, and then sharp rise. But actually the same thing happened, or has happened many times before, when the climate, the natural climate, shifts from glacial time to interglacial time. And currently, actually the last theories say that this other picture, this could represent 50 years of time where suddenly the temperature rose for 5 degrees. So really quickly and really much. And now I want to bring you into two studies we have been doing lately. very different ones. And the very first one is coming from northern Finland, up there, around the B. And there is a Turku University's research station, Arctic research, subarctic research station called Kevo. And in this station, the kind of very important part is that the ongoing monitoring has been done there since 60s, 70s. So we have data at very different objects of organisms and nature, which we can put together and find the way how they are related to each other. And the picture here is one of our trips to the northern Finland. I think it is last year, probably. And what we are doing there, in my group, is we are observing the pollen deposition in this environment, and specifically looking at the mountain birch distribution and the mountain birch pollen production. Annika is also a specialist of pollen, but in a totally different field as aerobiologist, and also the Kevo station of aerobiological research is one of the longest going in Finland. So to convince you once more that the climate is really changing and changing rapidly, this is the outcome of our climate kind of takeoff from Kevo station, meteorological station. And we have looked at the spring, summer, kind of all seasons climates, and then some general trends like really cold spells happening, the heat accumulation for summer, mean annual temperature and precipitations. And you can obviously see that all these curves turn upwards. Most easy probably to understand what happens is to look at this MAT, stands for mean annual temperature. And according to our results at Kevo, every 10 years, the temperature has been rising for ½ degree during these last 40 years. So every 10 years, we get ½ degree more in mean annual temperature, which means that there is really a quick change going on right now. How it affects the biota. And we were especially interested in something very simple. So we are looking at the interactions between mountain birch and its two major herbivorous predators. So it is a reindeer and geometrid moth there. And we were using pollen to monitor the changes because observations of actual kind of calculating the biomass or area of growth are not available for so long time perspective. And what we found was that actually the birch seems to be diminishing or feeling less happy in these warmer climates. At the same time, the moths are definitely doing much better. The curve for reindeer is falling, but this is not because reindeers are somehow affected by climate change. It is rather that Finnish government is concerned on holding the balance in ecosystem, and they are constantly lowering the amount of the reindeers allowed to have for Samis to keep the balance in ecosystem and not to tip it over. So, as a result, altogether, I tried to put it into a nice and round figure and not to bother you with huge tables. So these are the interconnections we found between all these elements. and you see 3 lines connecting all these different players. The outermost is direct impact. So if we had warm weather this year, then if it affected, for example, the population of moth directly. The second line in middle, this is a last year impact. So if we had warm weather last year, this could make a huge difference for this year populations. And the kind of innermost line is for that to show that actually there are even more lagged interactions. So you can have 3, 4, 5, or maybe 10 years lag between the impact and reaction. So the biological world is really tightly put together. And currently, what we can conclude from this study is actually that if it goes on, and we know already that besides the autumnal moth, which was a long-term only big predator for birch in this area, now there is another moth species moving in and having also outbreak densities. So lots of birch can be suffering more and more from that, and that means that in some point in time we can lose this community as it is right now. Unfortunately, I don't have any clue how much I have been talking because the timer is not on. But I will continue and hope that there is time. So that was just one place, what I was showing where we are monitoring the pollen, but actually there are quite a few more. We have a transect crossing the northern Finland and northern Norway from boreal forests up to the open tundra there. And then thanks to Lauri and Vivika here, we have also trap results from Svalbard, from Petuniabukten. And these nice pies here represent the proportion of tree pollen versus herb pollen we can see from these traps. And you can see this is a Svalbard. We practically have, of course, herbs, but there is still 5% of trees coming from this long-distance transportation, and you can imagine Svalbard. And the first tree is actually probably Norwegian coast or somewhere in Greenland, if there are any. And coming to the boreal forest, we get opposite picture. We get a huge amount of tree pollen and very little herb pollen. So what do we do with that and how to use it? This is now our very latest scientific project, which is still in progress. But this came from the fact that actually Europe's very last mammoth died in Estonia, in central Estonia, about 11,800 years ago. And the question is, why? You have probably all, at least from childhood, I remember very clearly some of children cartoons showing people running and killing mammoths and how so they ended. So what actually happened and what happened with our mammoths? We tried to put together every single bit of data we have. So this picture here is showing our last mammoths. So something 11,000, 15,000 years ago. And from Lithuania to Estonia, we have about 5 mammoth finds. During last glaciation, it is not like this, that the glacier comes, there is 2 kilometers of ice, and it stays there. Usually, there are more cold periods where ice is moving forward, and there are less cold periods when ice is moving away. This is probable ice edge at that time interval, so something 40,000 years ago. And there is a huge amount of mammoth finds through all these countries. The picture there is a mammoth tooth. Usually you have imagination of these big tusks going on, but actually most of our research is done on these teeth. And the results are like this. This is actually oxygen isotope curve, but it very nicely shows you the warmings and coolings of this 50,000 years. And this period is what I was just talking about, lots of mammoths. The blue ones are Estonian, red ones are Latvian, and green ones are Lithuanian. We don't know why there are so few in Latvia, but so it is. And if you're looking at the pie chart up there, this is a representation of pollen, sorry, of the climate or the vegetation, sorry, which was there. And hope it reminds you something. Oops. If you remember, this is exactly how the pie chart from Svalbard trap looked like. So probably no trees in hundreds of kilometers, just open steppe. If we are coming now to other side, to this our very last 5,000 years here, you see that we have few mammoths. They are strictly connected to cold periods. And if you're looking at the pies up there, which again represent pollen-based vegetation, you see that we have in warm period, we have more trees. Then in cold period, we have practically similar situation as down there. And with this very steep warming, we get lots of trees. So our mammoths actually really liked the environments without any trees. And this is again kind of contradictory to some of previous research when some of the Russian mammoths were found intact and their stomach was full of pine branches. And it was then reasoned that obviously this was their favorite food. According to this was their absolutely least favorite food, which probably killed them at the end. When looking up there, we have other proof of that, because the nitrogen level, which goes the x-axis, the yellow dots there are nitrogen signature of mammoths from here, and the green dots are the last mammoth signature. And you see the nitrogen depletion, which means obviously less nutritious food and more difficult to survive. I put also here the first known settlement of Estonia, and this is actually around 800 years younger than our last mammoth. So at least on our present knowledge, we rather believe that they died out because their diet was not enough nutritious, rather than people thought that they are very nutritious. So, thank you.
Hi. I was wondering, how do you connect the reindeer population in that graph where you had when you said that it's more human involved, so you can't really connect it so well with the
yeah, that was actually, yeah. That's obvious from also, oh, sorry, it was gone. That was also obvious from graph that it didn't have any connection to birch. It had slight connection to moth, and that's because if you have a strong moth attack and it eats up the foliage, that means that grazing for the reindeer is poorer, and that means that even if you have limit allowed for reindeers to have, you can't have them in this region because there is not enough fodder, and it is naturally reduced by farmers, of course, but then you can see this reduction.
Thank you very much. Now I would ask the next people who will talk about aerosols. Aerosols, they do not have borders. And we have two persons, Heikki Juninen, head of Laboratory of Atmospheric and Environmental from Tartu University, Institute of Physics. And Mikko Sipilä will continue, and she's from Finland.
Thank you. Hello. In a spirit of cooperation and example of this cooperation, we will have this talk joined with my good colleague Mikko Sipilä from University of Helsinki. But I'll start off and lay the head for him to tell more complicated stuff. How do I start? Do I have to press something? There's only 3 buttons. I'm headless, handless, hopeless. All right. Yes. So the talk is aerosol without borders. Borders is doesn't mean necessarily a border, a political border, or it can be a political border. It's really up to you how to interpret. Talk is about aerosols and the climate change. I bring up the old slide from 2016 from IPCC report because I find this more easy to explain than the new one that has been put up last year. And this slide, the red area is all anthropogenic factors that do affect climate by warming it. So anthropogenic, so humans' influence. And in the red, blue side, we have aerosols, or we have factors that do cool the climate, or at least that by some modeling. And we see majority, or most of the cooling part is associated with aerosols. So aerosols are only anthropogenic influence that we do to the climate that actually fights back the cooling. Obviously, it is all in balance. And the other big message here is the error bar, so the uncertainty associated with aerosols. So actually these error bars can be even bigger, so some aerosols do warm climate, not everybody, all aerosols are cooling climate. But the majority of these error bars is actually translated into the total effect of anthropogenic activities on a climate. So this uncertainty is mostly associated phenomenon that is associated with aerosols. Here is a list of sources of aerosols, and we will concentrate on this very, very last and the most important part, the atmospheric new particle formation, the mechanism of the atmosphere to make aerosols by itself, and how humans do play a role in making that. To oversimplify the whole process, we have a soil, we have a forest, we have a sea and water bodies, we have factories and cars and humans and everything that we live on a ground, and we do put molecules to atmosphere. And then the complicated photochemistry, mostly photochemistry starts, and we start to convert those molecules into something that doesn't want to be gas anymore. So there is mysterious process in atmosphere where the gas doesn't want to be gas anymore. It wants to be condensate out, to be atmospheric cluster, to be atmospheric particle, to grow so big that it can be a cloud droplet. This is the take-home message. 80% of cloud droplets that we see out there are formed on particles that were gases when they were emitted. So to say, secondary particles that are formed in atmosphere through atmospheric processes. And this is what we study. How common it is, this is example of new particle formation events. Normally, the event is one event per day. So there is one day when particles are formed, next day they are not formed. So there is these particle formation events, and there is tens of thousands of particles formed, and it happens everywhere. It happens sometimes so that all our stations in Estonia, Finland, up north there, they all see the same new particle formation event at the same time. So you could see all 3 stations or 4 stations, and we see it everywhere. Sometimes it happens only in one station. So it's a little bit like a cloud cover if you look from the satellite. Sometimes it's big, sometimes it's small, but it can be huge. In a total region, there is new particles formed. And if you calculate those days when particles are formed compared to the days when particles are not formed, we get this ratio here. So 0.8 would mean 80% of days particles were formed in a month of January. So actually in January, we see there is very few particles formed. The colors are here, different stations, one in Estonia and 2 in Finland. And there is 2 messages here. One is that there is a massive peak during the springtime. And there is almost no particle formation days during the wintertime. So it is clearly related to the yearly cycle, and clearly related to biology. That's where nature starts to wake up from the winter sleep and starts to emit lots of biological VOCs, volatile organic compounds, to the atmosphere, which starts to oxidize. And oxidation products are low volatile, and they want to condensate and make particles in order to be seeds for the clouds. The cloud formation is a meteorology, but in order for the cloud to form, we need those seeds, the particles, to form on. So springtime, massive new particle formation events across the region. There is a little bit of a difference between the boreal forest, hemiboreal forest, and then very Nordic ecosystems in intensities, but the yearly pattern is very similar. Hemiboreal forest, where we have lots of broadleaf trees on top of, or in addition to pine trees, does not have so strong new particle formation potential as the pine trees, the deciduous trees have. So that might explain the difference we see here between Estonia and in central Finland location, Hyutiala. Now, when looking back, the first measurements in Tahkuse station close to Pärnu started end of 80s. And then we divided here the days into aerosol passive days and aerosol active days. Active day means there is new particles formed, and passive means there is nothing related to new particles. And we do see here that this significant trend in having more aerosol non-active days. So there is less and less aerosols produced in our region by the atmosphere itself. It's roughly 2 days per year there is a less and less aerosol production. Clear reason for that, I don't know. Hypothesis is we cleaning out sulfur dioxide from atmosphere, which is one of the key mechanisms of making aerosols. We're cleaning out NOx pollution. That would be, maybe in this particular station there is less forest around the station, although, like I said, the phenomenon is regional. So this one forest around the station is not explaining what we see at the station. So it's a bigger, broader area. So the aerosol production potential of the atmosphere has changed over the time. And this is 35 years, which is a climatically relevant time scale already. So we can start to think about climate with this time scale. So in order to study that further, we have established and we have a network of stations that we have already existing data, and we're collecting new data. All of these stations have instrumentation that do measure aerosol formation, aerosol quality, aerosol size, and number concentration. And then in this brackets, I can mention all of these stations have an instrument that is developed and built in Tartu, some of the instruments. So there is a station north of Greenland, in Svalbard, Ny-Ålesund, and Värriö, Hüüdjälä, and 2 stations in Estonia, Järvselja, Prime Forest, and the Tahkuse station here. So this research is ongoing, and there is a very much of interesting and complicated chemistry involved. Don't concentrate on chemical equations here, but the message here is that aerosols, in order to form, we need oxidation. We need oxidation, we need ozone. And the Arctic is very special about having sometimes even very long periods of very active ozone depletion events. And this is one example from the paper last year, where this mechanism of how ozone has been depleted from atmosphere that is required for new particle formation. So this halogen chemistry related to snowpack emission of brominated chlorine gas has explaining these ozone depletion events in Arctic, which has been observed during the ship experiment in a Mosaic and in Station Nord and the Ny-Ålesund station. But not only in Arctic you can do Arctic-related work. There is experiment in CERN called Cloud experiment that concentrates on looking at different chemical mechanisms of new particle formation. And you see down here there are different kind of sources that is emitting something to atmosphere. And this something emitted to atmosphere has related to chemical mechanisms which are red here that the cloud chamber tries to study. Cloud chamber is CERN cloud chamber is very unique chamber in a sense that it's made with, let's say, CERN quality, which means ultra pure, ultra clean, ultra. Everything is very expensive and very, very clean. So you can really pin down the individual molecule by molecule mechanisms that we can do there in CERN. And at the moment, there are special Arctic-related questions being raised, and the whole this year, and 2 more years are concentrating on cold regions of atmosphere and which mechanisms are active in this Arctic or otherwise cold region. Cold region is also up there in free troposphere, minus 50, minus 30 degrees, where special chemistry happens. Quickly mentioning that we are part also of a Great Feedback European project where we concentrate on looking at greenhouse gas emissions from many Arctic stations. But with that, I will conclude and give word to Mikko Sipilä, tell about new particle formation mechanisms more in detail.
Okay, thank you. Thank you, Heikki. I'm Mikko Sipilä. I work at the University of Helsinki, its Institute for Atmospheric and Earth System Research. We have a research station in Finnish Lapland. It's called Värriö Research Station, and that's where I'm physically located, and I run the station. But I will tell something about the Arctic and Antarctic research, what we perform at the Institute, and a significant fraction of that is either made in collaboration, especially with Heikki. We have been on joint expeditions with him, and also we utilize internationally developed instruments, and as Heikki mentioned, one of the key instruments what we use and need in our studies is developed here in Estonia, in Tartu. And also we use software which is developed mainly by Heikki to analyze our results. So this Finnish-Estonian connection is super important for us as the Institute in order to be able to perform these studies. So we do nothing alone. We always do this work in collaboration with those who know their business, and here we certainly have people who know. Okay, I start with this photo. This is a satellite image from the Arctic Ocean, Svalbard is there on the top, and the green in the ocean is chlorophyll. There is a phytoplankton bloom ongoing in the ocean. And what is known, has been known for a long time, that this phytoplankton is producing a compound called dimethylsulfonopropionate in the ocean, which is then converted in microbiological processes to dimethyl sulfate that can be evaporated to the atmosphere. And this sulfur compound oxidizes in the atmosphere to form especially methane sulfonic acid and sulfuric acid. And these two compounds have been known that they probably can make new aerosol particles, the particles Heikki just explained, which are then important for the cloud cover because those particles can modify the cloud properties, and therefore for the climate globally, but especially here in the Arctic. Well, this figure is now pretty much what was known roughly a decade ago in the Arctic aerosol formation processes. So we have the phytoplankton here, the green dots, and it was known that this dimethyl sulfate comes from the ocean because of this plankton, and it forms sulfuric acid and methane sulfonic acid. Not much more was known. Then there were lots of question marks. What happens to these compounds? How they form these small little particles or clusters? How those clusters grow to particles which are large enough that they can modify clouds and eventually climate? And of course, we have much more stuff in the ocean than just this phytoplankton. We have, open ocean, but we have also sea ice. There is plankton living also within or underneath the sea ice. Is there something coming from the ice? We didn't know. There we have fish in the ocean. Birds are eating fish. Birds are pooping. There is guano, which may emit stuff like ammonia to the air. We have some vegetation in tundra-covered areas. We have snow. In the Antarctica, we have penguins and so on. And there are also stuff coming directly from the ocean, like sea salt particles, crystals, biological things. Dust and pollen may be flying around if there is vegetation nearby and so on. But mostly just question marks. So I have dedicated most of my career in figuring out what happens here. And this is now some of our field activities on this map. The color is also now showing the temperature, how much temperatures have changed in this area. Black ones are the annual mean temperatures, and the blue ones are November, December, January temperatures, so the midwinter temperatures. And you can see that they have increased quite significantly from pre-industrial times. But we have had campaigns in Greenland, in Station Nord, New Ålesund, Svalbard. We have had continuous measurements, a tiny little station in conjunction with Italian station in New Ålesund. We are measuring there right now. And the Mosaic expedition was an expedition with the Polarstern German icebreaker research vessel, which was parked to the sea ice during COVID years. For 1 full year. This my station is somewhere here, Värriö, where we have had continuous measurements more than 3 decades now. And similar stuff then in Antarctica. We are active at Marambio, which is Argentinian station in Antarctic Peninsula. Then we have continuous measurements at Concordia, and South Pole measurements are just about to start. They are operated by Americans and then Italians, respectively. We are not physically there, very much at least. Then we have our Finnish station, Apoa station, about which I think Britt Tiesler is somewhere here, will say something. Tomorrow I have been there with Preet a decade ago. And then Neumayer Station, German Station. These are the places where we have been collecting our data. And here are just some fancy photos from those expeditions. And after doing that research, what we have learned, we have been able to kind of complete this figure. So we conceptually understand and know how these particles form. So once again, the phytoplankton here emits dimethyl sulfide forming methane sulfonic acid and sulfuric acid. And then this sulfuric acid, I was too fast. But then we have this fish here, birds and penguins are eating fish, and their guano is producing ammonia. Okay, we have found that one is important as well. Tundra vegetation surprisingly produces quite a lot of organic compounds. And these organic compounds are oxidized to so-called heavily oxidized organic molecules. Then sea ice especially, and possibly also snowpack, they are emitting iodine compounds. Iodine produced in a way or the other by phytoplankton, which is living underneath or within the sea ice. There are question marks in the exact mechanisms how it goes to the atmosphere. But anyway, it comes from the sea ice, and it oxidized to things called iodic acid and iodose acid, which we discovered from the atmosphere 2016 or something with Heikki for the first time ever. And then we have also solved how these compounds now make new particles. And in the Arctic and Antarctic region, the most important mechanism, I would say, is this one where sulfuric acid goes together with ammonia and the influence of galactic cosmic radiation, which is ionizing the air. So they make tiny little clusters. Also, this iodic acid can make small little particles with iodose acid or with sulfuric acid. So this is a mechanism which is important over sea ice-covered regions like northern Greenland and whatever ice-covered Arctic regions. So these are like the two most important mechanisms. Then we have also the heavily oxidized organics, which may be quite important in tundra-covered regions like Svalbard coasts, whatever Greenland coasts, and so on, and so on. And these mechanisms can also like mix. So iodic acid can go together with sulfuric acid and ammonia and vice versa. And the heavily oxidized organics go together with sulfuric acid and so on. And then depending on the availability of these compounds, then pretty much all of these compounds can condense on these initial clusters and grow particles to the sizes where it can act as cloud condensation nuclei, affect cloud properties and climate. So after something like 15 years of work, we kind of know how these things happen. There are still some further research topics what we want to target. Next is the anthropogenic effects, anthropogenic air pollution from ships, from industry and so on, emitting especially sulfur dioxide and primary particles like soot. And how this influences the system in the Arctic and also in Antarctica is something we want to look in detail in the future as well. This is the end of our talk. Thank you very much, and we are very happy to answer your questions if you have some. The flying animal is my kids, like this kind of a toy owl, which I was transporting on all my expeditions everywhere and taking photos with penguins and whatever animals and other places. Yeah.
Excuse me, just one question. Although you mentioned that the influence of anthropogenic sources, you are still looking into that, but what does your gut tell you? Is the CO2, I mean sulfuric dioxide, also important factor in cloud-forming particles.
Yeah, sulfur dioxide is out of the anthropogenic gases. It's like the key gas which is causing this anthropogenic cooling climate effect Heikki was talking about. And sulfur dioxide, for example, at our Värriö research station in Finnish Lapland, we are located just like a few kilometers from Russian border and quite close, 100-150 kilometers away from Monchegorsk region, where there is lots of smelters and heavy industry which is emitting sulfur dioxide. And there we can see very clearly this anthropogenic sulfur dioxide contributing to particle formation. How much that is doing, contributing in the Arctic, I don't yet have a very good answer. But generally, in the whole world, the sulfur dioxide emissions are like, they have been like bending and then will be slowly going down. So the anthropogenic effects probably are to decrease in the future rather than increase. But we need to understand how they are acting now so that we can also predict or give some good guesses how the decrease in sulfur dioxide concentration will accelerate probably climate change in the future. So that's why we want to look that in a little bit more detail. Thank you.
We shall have the coffee break now, please.
tal on laua peal, tal on laua peal. Good evening, everybody. Good afternoon. I have a very great honor today to be a moderator of this discussion. My name is Toomas Kokovkin and I'm a member of the Estonian Polar Club. To be honest, there is a little bit of feeling of being in a theater. We have this makeup and spotlights and being on stage. So I hope that we shall have our discussion today so that we are not actors in the theater and you are just audience. We shall have a discussion for everybody. I have been in London in theater, in England, in London, in theater quite a few times. I was surprised how actively the audience participated in the play. So hope that we today will do the same. We have now, for more than 1 hour, to talk about the polar diplomacy. For those who could not participate today in the morning sessions, we had a really very, very hardcore science day today, with some insights into the history and in geopolitical situation, but mostly it was real science. One presentation was specifically about cooperation in early 20th century. It was about adventure of a Norwegian. So, but now this, where we are now, we have to somehow talk about diplomacy, which was not much under discussion during the day. And we have to find something to say about polar diplomacy. Polar means areas of Arctic and Antarctic regions, so how diplomacy applies to these regions. But because our conference has a title of Arctic and Antarctic Science Cooperation, then I, as a moderator, I would very much like to stream the discussion into the scientific cooperation. But of course, you are absolutely free to give your messages, which you mean are important. Today, when we go home, because the target audience here is mostly scientific audience, we will try to give a message on how the diplomacy can be incorporated more into scientific research, how it can facilitate the scientific research, and probably how the scientists and researchers can be diplomats in the global cooperation. So that's this setting I would see, but of course we shall see where we arrive. But before we can continue, I will kindly ask you to introduce yourselves. Please, can we start from you to introduce one by one who you are, what you're representing. Thank you.
Okay, thank you so much. Good afternoon, everybody. I'm Bo Olsen, General of the Ministry of Foreign Affairs of Chile. I'm a career diplomat, former ambassador concurrent here to Estonia. My background is full diplomacy, and I would love to share with you how these are the linkages between the Arctic and Antarctica from this vision from the south.
My name is Ulle Wiesen. Kas see töötab tal?
I do think it's on
Yeah.
now. Yeah. My name is Ole Wiesen. I'm coming from Norway. I am a special advisor at the Norwegian Polar Institute at the moment. I have been the director there for 6 years. I have also been the director of the University Center in Svalbard, which Rico outlined so very nicely about earlier today. My background is as a fishery biologist in the Institute of Marine Research in Bergen, where I've worked for 25 years. And as a special advisor, I am also back to science and occupied also with writing about science diplomacy. Thank you.
Hi, everybody.
No.
Can somebody switch it on? Because from here it's on. Can somebody switch it on? Thank you. I'm Kersti Kaljulaid, former president of Estonia from 16 to 21. I have, well, my education is natural science, like probably some others on this panel do. Right now I'm running President Kaljulaid Foundation, which is protecting weaker in our society and strengthening democratic processes, equality, and these aspects of the society. And I also do some foreign and defense policy work still in Munich conference, Globsec conference, Geotech Center, and some other things, also helping Ukrainians through Yalta European Strategy Forum, organizing conferences in Kiev right now in the wartime. Yes, it can be done, but it's tough. We're doing it.
Okay. My name is Valur Ingimundarson. I'm a professor of history at the University of Iceland. I am originally a Cold War historian, but then I moved more into contemporary things and about geopolitics, governance, Icelandic foreign security, and Arctic policies and political memory, for example, in the Balkans. So I'm into several things.
Hi, I'm Avelina Helm. I'm here as a science advisor to the Minister of Climate from the Ministry of Climate, where my task is to advise Minister on the policy making regarding the scientific impacts and steer the policies towards more inclusive of scientific findings. But I'm also a professor of restoration ecology at the University of Tartu, so I'm also naturalist in my education, and I also study and research environmental issues, mostly biodiversity related issues, ecosystem protection and human impacts on and climate change impacts on ecosystems, like many here as well.
Thank you very much. As you may notice that in the program we have a different name, so just to say that the climate change happens so rapidly, and also the decisions of the Ministry of the Climate the same.
Yes, our Secretary General had a very rapid task in another country. Diplomacy, definitely.
Good to have you here, Avelina. Today, if you remember what we discussed earlier, was mostly about Arctic region, because we are in the northern hemisphere, and countries representing here were mostly Arctic countries. But we have representative from the southern hemisphere, and tomorrow will be discussion and presentations about Antarctic. So I think it would be appropriate to start actually with the enlarging the dimension, geographical dimension of this discussion. And I will kindly ask Mr. Rodrigo to give first statements from your perspective, from the other side of the globe.
Well, thank you so much. I think it, coming from the south, in that sense, I think that the first message, I think that for us in the Ministry of Foreign Affairs is the way that you're conceiving scientific cooperation is very important, because the first thing that we conceived is that science is not neutral, in the sense that we need to have an umbrella under the political institution. For instance, in our case, the National Institute, the National Antarctic Institute, belongs to the Ministry of Foreign Affairs, has an independent budget. They discuss independently in the cross the budget of the National Antarctic Institute, but belongs to the Ministry of Affairs in the sense that is currently following the principles of our foreign policy. And the Antarctic issues is a very keen aspect and very important key role plays in our foreign policy, because we, even if we understand that the whole Antarctic treaty system is under, it's freezing politically speaking, no? But we have clearly a vision regarding sovereign purposes and jurisdictional reclamations that are freezing in the Antarctic zone, but we have 5, 6 bases currently working. For instance, in this season are clearly 5 bases working in a scientific way. Clearly the leadership in the bases is under the armed forces, but with a strong cooperation with the Ministry of Foreign Affairs and this National Antarctic Institute that belongs to the Ministry of Foreign Affairs. So this is the main focus that we have, and we are always considering, and in our internal talks with the National Institute, the Antarctic Institute, is always the need to conceive scientific cooperation under this umbrella, but at the same time, the scientific cooperation allow us to isolate sometimes some kind of multilateral fragmentation that we suffer, and it's a perfect scenario in order as well to have scientifics for every corner in the planet carrying and sharing the same purposes. And in that sense, on the other view, for instance, I understand that polar diplomacy means as well that we need a strong institutionality behind in order to deal with. For instance, in the Antarctic treaty system, we have different bodies that works clearly in a scientific dimension, a scientific approach. So for instance, we have the SCAR. We hosted a month ago the big meeting of the SCAR in Pucón in Chile, where it was a venue where you have a strong community, international scientific community in our country, sharing their views and providing us all the good benefits that the science could provide us as a country. So it was a very good exchange of views of the different scientists there. And the other important for us as a ministry is to have a strong dimension of multidisciplinary approach with other ministries that belongs to the public administration. So Antarctic issues are clearly a very important issue in the Ministry of Science, as well in the Ministry of Defense, and in the Ministry of Environment. So this whole ecosystem works on behalf of a very good approach regarding scientific and providing funds from the different communities of scientists. And at the same time, as Ministry of Foreign Affairs, we clearly work in a bilateral way, helping to create the exchange between scientific communities. For instance, today we have we had the second round of political consultation with the Estonian Ministry of Foreign Affairs, and we have signed a letter of intent in polar cooperation in order to facilitate and in order to enhance cooperation between the respective scientific communities. So it's a very good instrument that we could provide to the scientific community in order to keep connected to each other in this way. Even we have very participatory and inclusive approach that we facilitate contacts with the participation with the civil society as well, because we are really keen on doing this, and the participation of women as a scientist in the program. So this is clearly important for us. We are just conducting a feminist foreign policy, so the government is fostering the presence of women under the leadership of different programs in the scientific community.
Thank you. Ulla Arve, you wanted to add something?
Yes, of course, coming from Norway, our main focus is the Arctic. Our northernmost counties are in the Arctic, and we are every day focusing on the sovereignty of Svalbard and the research we are doing there and the community of Longyearbyen and so on. But we also have a substantial interest in the Antarctic, and a very good cooperation with Chile, among others, the INACH, the Chilean Polar Institute, and taking part in the scientific community there and the Antarctic treaty system. And this is so important for Norway that one of the main projects in the years to come is to modernize the research station we have in Dronningmodland, the Troll Station. It's going to cost something like 2.4 billion Norwegian kroner. It's not a large facility. It will be for 65 people, but it is up in the mountains and very costly. But this shows the Norwegian government's priority regarding the Antarctica. We want to be a serious actor in the Antarctic treaty system. We are participating in the scientific community in SCAR. I personally had a role in taking part in developing the new research strategy for SCAR, which is called Urgent Messages from the South. We see substantial changes in Antarctica. Melting is going on in Western Antarctica. The ecosystem on land is changing, and in the sea we see acidification. There is a southward migration of marine organisms like the krill resource and so on. And it is important for us, even if we are a small but a bipolar country, to say that we also are relevant in Antarctica. And the next big scientific conference about Antarctica, the SCAR conference in 2026, will be in Oslo. So I invite you to come to Oslo in that sense in August in 2026. Thank you.
Thank you. Mrs. Kersti, you are well known in Estonia as an Antarctic sailor. But maybe please give us some insights about also this dimension of Antarctic and polar cooperation.
First, I would like to say that Estonia has applied to join the Arctic Council, and my then colleague Sauli Niinistö was very enthusiastic about our application, and we did everything to join. But as it takes anonymous, you have to have a kind. Everybody has to support newcomers. Then obviously we may have one neighbor who was not so interested in allowing Estonia to join. So this is still work in progress. Second, on Antarctic, yes, I was there, yes, and frankly that was one of the best and cheapest advertising campaigns for Estonia, because you know, we are a digital nation, and this is well known globally, but not maybe in every big company we have been seen this way. But because when I was there, then Inmarsat was testing their new generation of satellites, and it was advertised that it might be fast enough connection now to allow Estonian digital signature to be given from Antarctica. And it was possible. We did it. And then the company used only 3 use cases to, I mean, promote and prove their new satellites orbiting the world. And one of them was me giving signature, Estonian digital signature. And you can see, I mean, the advertising value for country, which we got for free, I mean, because we did it. So it was, I believe, one of the best and at the same time least known kind of advertisement campaigns run, I mean, to make Estonia bigger than it is. Similarly, Estonia was, when I was in office, running for the UN Security Council membership, and that meant that we really cozied up with countries on the southern hemisphere. And we did work a lot also with Latin America and of course this part which I would say, I don't like the name, but it's called South-South. So basically for me, I mean, I work with Africa and I work with Latin America and CARICOM and Pacific Islands, and I don't like this name at all. I think this is not fair and kind of has this kind of Europocentric or Northern Hemisphere-centric sound to it. But indeed, I was in Antarctic and we visited quite many polar bases there as well. And what I noticed was, and maybe it's not very diplomatic to say so, but because you can only establish scientific bases in Antarctic, then everybody is building laboratories with additional arms, which is, I mean, for countries from your part of the world, I think it's perfectly natural because you want to be there if, as you so nicely put it, if the kind of Antarctic agreement system freezes while the continent is melting, then there might be interesting developments geopolitically. So your presence there is perfectly understandable from that point of view. But I don't think people in this country or even on this hemisphere think too much about it. But this is clearly going on there, which means you find quite a lot of underused scientific equipment and laboratories on the continent. And Estonians who had at that time kind of grandiose expectations that one day maybe we also will have bases in Antarctic for scientific reasons. Well, we put this kind of 2 and 2 together and came up with the proposal that actually Estonian scientists should cooperate with all these nice laboratories which already are there and certainly were not overused. So I know that Tarmo Soomere, who was the president of Estonian Academy of Science at that point, on my prompt took contact with some countries in the region, and some cooperation actually resulted from that. So this has been kind of where and how Estonia has been promoting its presence and visibility in the region for various reasons, and also been probably scientifically well and still is, I'm sure, able to cooperate and also add some value for everybody. I mean, for those with whom we cooperate and ourselves, because we actually have a long tradition of polar research. From the times of when we were living under Soviet occupation, our scientists were able to work in Soviet bases, but also later on we have had Estonian scientists participating in Arctic missions, like being on this French ship which was stuck in ice for one whole winter season, and I mean some other expeditions where Timo Palo has been present and some other scientists. So we have been we have kind of a cluster of scientists who do polar research. And of course, not being a big nation, this is kind of innovative ways and kind of, let's say, tailor-made and out-of-the-box solutions, which you have to look for to participate in scientific cooperation. Politically, yes, our message has been clear and still is clear. We are a responsible country who worries about climate change. We have scientists who can contribute to analyzing and understanding processes, and this is what we plan to do also in the future. So notwithstanding any travels, I think we have a kind of coherent proposal for nations who work in Arctic and in Antarctic that, I mean, we can do things together and they're valuable things.
Thank you. Mr. Valur, I know that you are a specialist in governance and in geopolitics. We shall speak about governance maybe a little bit later when we come to this point. But please, can you add from the perspective of geopolitics what you have heard and how it can be related to the scientific research?
Yeah, just a couple of points. What the Antarctica and the Arctic have now in common is kind of a weakening of a collaborative or cooperative governance regimes, both cases. During the Cold War, the Antarctica Treaty was basically underwritten by the United States and the Soviet Union, freezing all the territorial claims. They have not been legitimized, but they've been frozen. So it was, after that, this collaborative regime was maintained. During the Cold War, of course, in the Arctic, it was a militarized region. But after the end of the Cold War, this notion, what Mikhail Gorbachev called the zone of peace, entered into the frame, and basically that has been, and this notion of Arctic exceptionalism. And this is a special region with, where everybody was collaborating. I mean, in both cases, these perceptions and projections are now in threat. No, they're under threat. In Antarctica, what we are seeing now, is there is very little kind of agreement on things. There was a conference last month. There was every environmentally protective measure was vetoed, for example, and in discussions, there is, countries, they vote along geopolitical lines. So, and now there are new bases, scientific bases are being set up, often near natural resource-rich areas, with raising the question of whether this is a harbinger of what is to come, whether a race for natural resources, or whether either just if one or two countries begin just to or discount or reject this regime, collaborative regime, or begin to undermine the treaty, by not abiding by monitoring mechanisms or surveillance mechanisms. And you can see this could happen there. In the Arctic, of course, now after the geopolitical turn, I mean, the Arctic Council is basically dysfunctional. I mean, there are just 7 Western states now with and Russia. And of course, the good thing is at least since we are talking about science cooperation, is kind of the working groups are still, in place, but of course under a much weakened position. So we can discuss more later what will happen. I don't know, but there is a sense that this whole cooperation in the Arctic could break up.
Let's keep it for the later discussion. Thank you, Avelina. Thank you.
Yeah, I continue with this from much simpler perspective. Like when you're working in a ministry, then you sometimes have to convince people or administrative offices or politicians in importance of having the collaboration in the Arctic region, in the polar regions, and all the time. I know many people here are familiar with it, have to prove that this is in Estonian interests to act in these regions as well, as a small country, non-Arctic country, but still the northernmost, and with a lot of expertise in the respective fields. So if just to outline these important topics that make polar regions so relevant in Estonia or to Estonia or actually to whole EU, then I think the changes that will come very rapidly and are already there with the climate change place our region of the world and your region of the world to the very center of the changes. It is like a powerhouse is a positive word, but the powerhouse of negative changes in a way as well regarding the rapid geopolitical and security aspects that we heard previously, but also very rapid environmental changes that we are going to face and that the Arctics and the Antarctics are already facing. So from Estonian context, I think these changes, they place us together with our neighboring countries and the other EU in the very center of the world because of the importance of polar areas in the future, in the geopolicy and security and the environment. But I also wanted to remind that I'm very glad that today is the day that Chilean Ministry of Foreign Affairs is here, and I understand you signed the memorandum of understanding because the scientific work between two countries has been very successful and very positive and friendly, as I have heard, and future looking, and I'm very glad that this is also now in a way official or thinking in the same terms. But Estonia has a long history and in Antarctic as well, that already our German Baltic captains of 18th century, 19th century, they were the first one to make a voyage around the world. Captain von Krusenstern was of Estonian origin, and he was followed by Captain von Bellingshausen, who was apparently or claimedly the first one to observe Antarctics, and they are both of Estonian origin. So our kind of long-lasting love of polar region is embedded in our cultural history as well, and we have a number of writers who have also carried it through our culture. So I'm very glad that we have this kind of strong community. First, a community small, around maybe 50 scientists, small but very strong community of polar researchers, and we have diplomatic connections with countries. Estonia is working towards also being a member of the Madrid Environmental Protection Convention, Antarctic Treaty Convention of Environmental Protection. It has been a long-lasting process, but we'll see where it goes and how it will happen. Currently, I think we again discuss budgets and related costs. But nevertheless, I'm very happy that we have all these diplomatic and scientific collaborations, and the science is the best diplomacy, isn't it?
I think so, yes. But may I add to the information about the Estonians going to ground the world? A small island of Hiiumaa, had a ship named Hiiumaa in 1854. The Maritime Museum may correct me, already went around the Cape Horn to take fertilizers from Peru. So I'm sure they went to Chile as well. But please, audience, now you know our distinguished guests. Please do have already some questions or comments about the topic.
Meanwhile, I think it's still worth reminding and telling also our foreign colleagues here that Krusenstern and Bellingshausen, of course, were of German origin. I mean, they were Baltic Germans, and then Bellingshausen served in, 4 Russians basically equipped his ship in UK, so it was a truly multilateral process of discovering Antarctic. But indeed, when it was around the anniversary of seeing Antarctic first time, then we actually had a very interesting situation where an Estonian ship landed in Antarctic, and we met with our Russian neighbors with whom we had relatively better relations at that point of time than now, and we celebrated together in the Bellingshausen bases in Antarctic this, and we actually had our Estonian central bank had issued a coin for this occasion, and we presented it in that Russian base. And so it was kind of funny that we kind of had a joint celebration, and this is just to show you how quickly relations have, got worse around also Antarctic and Arctic questions. I think it very nicely illustrates what you said. There is a risk of a collapse of cooperation even, and that was, when it was 200th anniversary of sighting Antarctic, when the ship went. It's not so long ago, less than a decade. So things change really quickly.
Kas meil on mikrofone veel või võtame siit? Näed siin esireas, proua.
Thank you. My name is Reet Kokovkin and I am from the Baltic island of Hiiumaa. And we very clearly remember that the Baltic once was totally frozen. It was in, was it 17th century? Yeah?
I don't remember.
Well, we remember. But coming to the cooperation and worsening of the cooperation, how are the sanctions actually applied towards Russia because of this aggression? It has not only in Russia, in Ukraine, but also all over the world now. So we know that well, we all know that the Russian scientific base in Svalbard, it has very little to do with the science, actually. So how the sanctions are applied in the Nordic sphere? Yeah, thank you.
Please.
Yes, if I may outline an answer. From the Norwegian side, the bilateral relations to Russia are on ice. That's the official version. At the same time, the authorities allow scientist-to-scientist contact. For instance, regarding polar scientific issues, common projects, and so on, there are personal contacts with Russian scientists so that time series are maintained and data for various projects are collected. And this policy was developed immediately after the Russian attack on Ukraine on the 24th of March in 2022. Just a matter of days afterwards, the policy was coming from the Ministry of Foreign Affairs and the Ministry of Climate and Environment. So there is some contact, and especially regarding, for instance, the living resources in the Barents Sea, the large fish stocks, which is so vital for Norwegian economy, especially in the coastal areas in the northernmost counties. There is close contact with Russian scientists, so that, for instance, the joint Norwegian-Russian Fishery Commission has recently had its meeting, digitally, of course, on Teams or on Zoom. And on the basis of the scientific advice developed in agreement with the Norwegian scientist and the Russian scientist, there was a political decision on the level of the quotas for next year. And they still follow the scientific advices quite closely. It was deviated a little, but the science is the basis for this cooperation. So there is contact, and it is possible to establish, if there is a solution in Ukraine or something, it is a possibility to quite quickly re-establish the relations. There are, of course, other issues that may make this difficult, but there is some contact so that we can have a certain relation, but it is much lower than before, and it's strictly to the point. So the email exchange, for instance, is very technical, very scientific. There is nothing about the weather or how the life is as it was in the 90s and 2000, for instance. We have personal relationships to many of the researchers, of course, but this is gone. There is no comment on anything, just the technical issues. Thank you.
Thank you. It was a very good message from your side now that actually as you also emphasized, the science is the way to make diplomacy and to keep some level even at the very difficult times. But somebody said that there are rapid changes. And today the whole morning was about showing us that there are rapid changes in climate, that there is warming, at least in the northern hemisphere. from the presentations. And from your perspective, from your expertise, does this already influence your understanding of how things go on? How are the not only political but positional, geopolitical changes in the world related to the climate change? And do you expect that scientists can do something more apart from studying and declaring the existing change? Is there any tool more for the scientists in this situation?
If I may, I mean, from the political viewpoint, and Avelina and others can maybe support also from the scientific viewpoint, but from the political viewpoint, here in Europe we have actually agreed collectively to, and maybe unknowingly, to give up some of our economic supremacy globally in order to, I mean, go clean and demonstrate that kind of a developed economies can also use less the resources of this planet, and actually I think we are paying quite a lot for that. The whole Europe is suffering from the lack of energy, because basically nobody has been investing into the dirty energy production, and also because there has been really unclarity about, I mean, how this new green market for energy will operate, and also investments into the green without government subsidies has been very difficult to obtain. So basically we've broken up European common market in order to be able to subsidize energy, and we have even not consciously announced that we've broken up the European Union common market. But we're just doing it. Everybody is subsidizing their energy production and clean energy creation. But since energy is omnipresent in absolutely every economic sector, then the common European market cannot function if the energy market cannot function. So there is considerable economic, which means also socio-economic damage to European economy, because we consciously choose to lead on this planet for the green change. We could have done it better. We could have been, I mean, more kind of giving more foresight into the, into this new market function. We have not been able to do it, but at least we have decided that green we go and clean we go by the 2050. And because this message from this quite rich and big market, because it is still one of the richest and biggest markets globally if you take us together, this message penetrated into the corporate sphere. And this means that by now, and I think this is the achievement of the European kind of common politics and policy making on green turn, is that now, when basically we can stop COPs and we can have COP conferences where the leading nation comes out and says that oil is a fantastic stuff and we should continue using it as intensely as possible, it wouldn't change. Because quite a lot of investment, quite a lot of research on the private sector side has gone into the green turn, so that these sunken costs there now are so considerable that turning back is not possible. So we will trudge on. And I was present in one conference where one leader of a big company, it was not an open conference, it was Chatham, so I cannot say who, but he said that he has the feeling that everything which, when you start doing things, looks kind of impossible, it is starting to look more and more inevitable. So basically, scientists, of course, need to keep measuring and warning and telling us what is going wrong. But politicians can actually rest their feet, put them up and now enjoy, because big companies have decided to go green. And they will go green, because they have now it's the race to the bottom that way. And it will happen. Of course, I mean, politicians anyway have been the weakest part of this pact. It's always been more like scientists and economy. And politicians, if they had known that, for example, Europe will have these socio-economic consequences, probably will not have dared to decide, but they didn't know, and they kind of sleepwalked into this situation. But I mean, finally, when the humankind comes out at the other end, I think Europe can be proud of this achievement. And finally, also, Europe will also gain, because quite many green technologies have been fostered here in Europe. So this means, finally, I mean, we will also gain from having developed these technologies and put their development cost down. So it's a kind of a very long process, very hard to explain. I don't know those who have high gas prices right now in Europe. But I think Europe has done something really valuable, which we should actually be proud of.
Yes, I can only agree. I was just in the last COP in Azerbaijan, which is a oil-rich country, and there was very the distinction or division was actually very, very visible. But it does not, as Kersti put it very well, that it does not change the course anymore. And I think even the other political changes that we have across the world won't change this course. But I agree that Europe has been a leader in this. It was, again, it has been shown in every COP, although, again, as Kersti put it very nicely, we can leave the COPs, and in this regard, regarding the transition, this will start to happen, and this will continue to happen. But where we are lacking, and I think in the case of polar regions and in geopolitical regions, geopolitical context, what is more and more influential is the actual impact of the change and our ability to adapt with it, and our neighbors and not friendly neighbors and not so friendly neighbors. Plans of how they plan to adapt with it and make use of these changes. Arctic regions, polar regions, they have this huge overspilling impact to Europe, to the world. So it's like this very, very strong driver of change. But what I think there are a number of countries who are keenly waiting for these changes to reach some kind of threshold in order to start pushing into the agenda that they might have already long time. I don't know whether Europe has this kind of future notion or agenda for the future to counteract those trends. But I think we should have, because we are facing simultaneously changing environmental conditions that make us weaker, and our own ability to adapt more difficult, plus simultaneously very big change and interesting drivers from other countries and their decisions on what was actually very well also outlined in the US policy perspective that was put up there. Yeah, so adaptation to changes, environmental and geopolitical.
There is an important point I would like to raise regarding the role of science, which was your question for promoting polar diplomacy, and the scientific community have quite a long perspective. From time to time there have been polar years. The last one was in 2008, 2009. Big international campaigns both in the Arctic and in Antarctica. And the next one is going to be in 2032, 2033. So 8-9 years from now. It takes time to plan such big campaigns in the different nations, and then to align the different projects between the nations. And there are many scientific organizations that will be involved and so on. The SCAR, the scientific community in Antarctica, and the IASC, the International Arctic Science Community up north in Arctic, will have a leading role in doing this. And it's a possibility for all nations to participate. In Norway, we have now established a national committee for starting to plan what shall be our contributions, and it's up to other nations to join in. And in this respect, the scientific community is aligning itself so that they can underpin and contribute to a polar diplomacy, which is more needed now than in many years because of the geopolitical difficulties. At the same time, there is a sense of urgency, really a sense of urgency, which makes this green transition, which was spoken so very well of with the two colleagues here, because we see changes in the polar regions, which is really dramatic. I have been 2 years ago on the North Pole with our polar research vessel, Kronprins Haakon, named after the Norwegian Crown Prince. And to our surprise, it was so open. There was still ice, but it was so open that it was possible to trawl with a pelagic trawler. It was possible to fish. Just, let's say, 15 years ago, we had scientists on board that vessel which landed on the Russian Boreal station, which was there every summer. They could land on a plane. There was a bulldozer making the runway and so on. And that is not possible anymore because it is an area with, of course, there is ice and ice flows and so on, but a lot of leads, which makes it possible even to fish. We didn't catch anything, but that was not the main point. The main point was that it was so very open. And in Antarctica, in the Troll Station, up in the mountains at high altitude, where we very rarely see water, I have seen running meltwater myself when I've been there also. So there is really a sense of urgency of what is going on with our Earth system at the moment, and with the greenhouse gases and the temperature rise and so on, and we need this green transition, and the scientific community has an important role in underpinning that by presenting knowledge, even to those who won't listen. But I worked with Norwegian fishermen for 25 years, and if you continue and continue and continue with giving messages that this is the development, finally it goes in. Thank you.
Yeah, thank you. Yeah, I think the role of science in the decision-making process is something that has been changed. At least in our regional group, in the GRULAC, in the Latin American groups, in the multilateral level, even the bilateral level, the way that the countries from the south are facing, for instance, the negotiation processes right now is clearly different that we usually had 20 or 30 years ago. The way that the scientific community is clearly involved in the decision-making process is something that expresses the need of urgency, the need to act now that we have. And clearly the climate ambition in this way and the energy transition policies that we have at the domestic level is clearly show us the role of the science, how has been have been evolving the last time. For instance, in my experience, at least in the BBNJ treaty, in the High Seas Treaty is clearly like that. It's a very multidisciplinary approach in the way that we negotiate with others internally and then with the others in the UN forum. For instance, integrating people from the science, scientific, people from the scientific community, people from the private sector that represent the interests, for instance, from the fisheries in the BBNJ treaty, people from civil society. We decided to incorporate people from the civil society in our national delegation. I think it's a very interesting approach. It's not only Chilean one. I could observe that is something that, at least in the Latin American region, it's clearly getting even normal. I think that to count on scientific evidence is clearly a strong basis for us as a diplomat in order to incorporate the scientific dimension in the foreign policy approach. We are getting stronger and stronger if we incorporate and we are adding the scientific spectrum in our final decision. I think it's evident and we need to do that in every aspect of the current negotiation process that we're facing right now.
I just wanted to say that maybe it's also interesting to talk a little bit why, but in Estonia, actually, Estonian scientific community has done a notoriously bad job of helping our politicians to get this message through to our citizens, that this is a serious thing. Despite the fact that, I mean, you go outside and you get +10 in end of November, very few people are scared. And this change has been extremely rapid. I mean, if you look back at the last 4 or 5 years, then this kind of, it seems to be kind of a hockey stick turn point also for this country. Yet, even in our own Academy of Science, some elderly academicians, advocate for sustaining polluting technologies in this country, which makes economic transition to green economy in this country particularly difficult. And I feel our scientists have actually failed our community in putting this message through, which now results in a lost decade in our industry because we didn't take this seriously. I've myself given up on convincing our citizens on climate change. What I've instead been doing for 10 years now has been like, look, our main trading partners go green and clean. So you just lose your economy, which is now happening. But because this message from science in Estonia has been far from loud and clear, and delivered with a single voice, that we need to, wean ourselves from polluting technologies. This country is now actually suffering economically, and this is the fault also of our scientific community.
Kadri and Tam from Tallinn Technology University, from Department of Energy Technology. So actually, Kersti, thank you. You were almost going my thoughts also. And actually I was just thinking that if we are like developing very fantastic technology, which will help not only our area, but all polar areas. But one thing what we can do is like we're presenting the papers, we will participate the conferences. So what you suggest, what as we as scientists should do that, how can we improve our voice at that, and our voice will like cover the global. So what you suggest?
I think every scientist should first speak only based on their own scientific capabilities. So if you are an energy scientist, don't speak for climate, vice versa, listen to your colleagues, listen to Adelina and others, who are specialists in this area. If you are, gene technologist, don't speak on the social sciences if you don't understand, what is going on there. This is my message to scientists, but I'm not a scientist. How can I teach the smartest people of all? But that somehow, Estonian scientific community has indeed failed to speak with one voice, and this is the biggest problem. And you see where these voices that it's not a problem is coming. It's coming from energy and the oil shale sector, which in Estonia is very strong. Also, oil shale is science in Estonia because we're very proud what we can do of oil shale. So in a way, I would say that get your own house in order, then you are more convincing.
I want to bring take kind of from the tail of this discussion and perhaps steer it back to the changing polar regions. That maybe this is one of the unused opportunity or one emerging opportunity that the polar regions, unfortunately, are also the regions of several dangerous tipping points, which might already be happening. We don't know that, but we can predict that if they are not already happening, they are likely to happen or might happen. The tipping points that make large changes in the climate system and kind of inevitably trigger other changes after them, which is, for example, the melting of the ice of the Arctics or opening up the Arctic Ocean and methane emissions and so on. So maybe we can also discuss on this sense that how we can put this good scientific knowledge and collaboration into good use in policy making while using this very rapidly changing visible environment that we all feel and can use better for communication. This is the sense of urgency and sense of danger is here, I think, everywhere. So Yeah.
Thank you.
It's just a question or, yeah.
Just want to add one point about, I totally agree with that scientists and scholars should be involved in this climate debate and try to pressure politicians. But I also want to point to one thing, that sometimes, and I know that scholars are reluctant to become involved in political debates, and particularly since often, particularly if governments are anti, green, then they can be punished. Politicians who control budgets, it will affect them, or then they also begin to talk down to scholars and scientists. They are a nuisance. They are into politics. This is just part of politics. So I just want to say that this is a fact, really. In this, I don't know about Estonia, but elsewhere that I've been involved in, that politicians sometimes penalize scientists who speak up.
Yeah, but I mean, this is unfair. I mean, everybody. I mean, if you speak up, then you are being brave. And I mean, if we felt this way that you may be penalized, then I'm sorry, there is a larger cause. I had a boss who was prime minister in this country. I was his advisor, and he always said, yes, I will do these unpopular things because I know that people will later understand this was right. And I mean, sometimes it's worth to be penalized if you know that you are standing for the right cause. And indeed, scientists tend to be cowards, I agree. I mean, thinking of the finance and everything. In Europe, this is not an argument because you have the European Union Research and Development Foundation, go seek there. Particularly for smaller countries, not a problem. I mean that if local politicians really shun you, but this has not been the case in Estonia, frankly speaking. Because in Estonia, politicians have really rather felt that they are left alone. I mean, it's like, I need your arguments. And they're not loud enough to make people to, believe. And I have this feeling like politicians have been left alone, not that politicians are not ready to, Estonian politicians are applying European green messages and being penalized, because people don't vote for green policies. This means we are left behind, left actually alone, standing alone there without scientific support. And that's our problem. So it may be different maybe in some other countries, but in this country it's this way.
Ma nägin teid. We have been working now for more than an hour. You have given a very strong picture of where we are. And before we go further we are starting to wrap up. But before we go further, I just asked any new questions from the audience. Please, the lady in the first row and then you.
Thank you. The melting of the ice, which is a catastrophe for globally, it opens, in many cases, very lucrative and aggressive possibilities for digging and searching and finding and using these natural resources that were kept under the ice so far. What can scientific and diplomatic and political sphere do if these diggers and foundings are done by not so very friendly communities? Thank you. States.
Maybe we can take the other question too, so we can choose answers. Otherwise, we run out of time answering this one. So there was one, I think. Over there.
Thank you. Martin Lira from Geological Survey of Estonia. So I'm more concerned about the geopolitics. And my history teacher told me that all the international agreements are made to be broken. It's just a matter of time. So you as a politician or close to politicians, what do you think, what kind of world will be when the Svalbard Treaty or Antarctic Treaty or the Arctic Council is already brain dead? So what will happen and what kind of perspectives we can have in this sense? Thank you.
Interestingly, this was the same question, actually. I mean, breaking down of these treaties a collateral damage. I mean, we are right now in a huge geopolitical shift where, I mean, good ones need to understand quickly that, I mean, they need to all stick together, have more free trade among themselves, more common objectives, and stand up against the bad ones, and forget the economic benefits of really getting on along with the bad ones right now. So, I mean, if this can be done, then all these other issues can be handled as well. Otherwise, indeed, I think it's a collateral damage that also these agreements will suffer because there is no multilateralism. How to fight it? I think since Peloponnesus Wars, people, I mean, humankind have kept, I mean, kind of building gradually a kind of a multilateral cooperation order which respects, I mean, human and national rights, and then it all breaks down and we restart again. I'm sorry, I'm a pessimist in this context. I think this is where we now are. We are in this breakdown phase. There will be a build-up, but maybe it will be a much smaller humankind because meanwhile we will miss, I mean, these kind of dramatic climatic changes.
Yeah, I think that we need, particularly in this uncertain times that we are facing, we need to appeal for a rule-based order. So we need to believe in that. We need to foster and strengthening the whole system, even if we could be pessimistic regarding how it's working right now. For instance, the whole United Nations ecosystem, but it's the framework that we have. So we need to still believe in us as an international community, and we need rules. We need a rule-based order, particularly if we're facing two conflicts nowadays. And obviously, if you have war in your backyard, obviously the objective of a sustainable development world is clearly entering a conflict of even regarding funding or financial aspects regarding these two urgent crises that you have to face. No? The environmental crisis, the need for more renewable energy, energy transition in our countries obviously have an impact. No? But I think that at least countries, intermediate-sized countries like Chile, we need to be attached more and more to stronger institutionality, particularly in the international community. We need to believe that. And then, well, I don't know how it's going to be evolving in the future. So yeah, we could be pessimistic, but at the same time, we need to foster, for instance, international cooperation in the different dimensions. Even, okay, UNFCCC, the last COP in Baku, someone could consider that it wasn't that good, but, well, there was an answer at the very end regarding climate finance. Maybe it's not the best, but we need to keep working on that and believe in us as a community. There's no way out.
I just plan to turn towards the future and ask about what shall we do, but you already started this answer now. And please, word is yours.
I have to say also I'm a pessimist. But now, and also there are divisions, for example, within the Arctic Council, among the Arctic, the Western Arctic states. I mean, whether the system is irreparably broken or whether it can be amended. And that's, of course, the big question. And now I think for those who say we should show, well, the phrase is strategic patience or whatever, you know, just not rock the boat too much at this phase, is because the alternative is worse. Because the Russia, for example, can just create another organization that's what is being discussed with friendly states, you know, BRICS states or someone who want to be could be brought in, and then it will be a total division, Cold War division, you know, again. So that is what is being discussed now. And for that reason, I think, and you could hear our American contributor, she didn't go, and she was basically parroting a lot the American position, but she did not go so far as saying this is totally broke. I mean, we want to see what will come out of it. So yeah, that's basically the option now, whether we continue and see what will happen in Ukraine. It will very much depend on what's happened there. And, or we are faced with a new Cold War in the Arctic.
Did you want to add?
Yes, I can, I choose to be an optimist. And this is because my background is as a fisherman, actually. As a fisherman, you have to have an optimistic view. The natural resources are renewing itself every year. The large fish stocks coming to the coast and out in the Norwegian Sea, on the Barents Sea, and they're renewing themselves and bringing large biomasses to the coast available for catching and so on. But my career has since been in science, and I see that the scientific community is aligning itself to be able to underpin polar diplomacy in a very good way in the years to come. I'm quite sure, because I see a substantial build-up for the polar years, 2032, 2033. It will be a big effort, I'm sure. And the scientific organizations are functioning very well. We have now, just a few years ago, we had 2 years where we didn't travel. We stayed in our homes, maybe in our offices, but we didn't travel. Still, we were able to keep the international cooperation on a very high level. Nobody could foresee what we were able to do in the years of COVID. We run the Antarctic Scientific Organization, for instance, elected new chairmen, developed programs, and were able to keep contact. My computer during these meetings were taken over by computer company in Melbourne, who saw that I have a fast enough internet to be able to participate in these meetings, and my picture was there, and I could speak and vote and so on. So we have a technology which we didn't have some years ago, and we are able to keep contact, and I'm sure the smart people of the world are going to see too that the world will function and not collapse in an ice front or a new Cold War. That's it is not the time for that. I mean, the changes that we see on the basis of the way we have been living, using fossil energy and so on, we need to underpin this green shift with new technology, and the role of science is definitely to be outspoken and again provide the knowledge that the society need for a sustainable development for the years to come. Thank you.
I am an idealistic optimist with a very realistic and low bar that is very easy, very easy to. Well, I am never surprised if things go not so well. My bar of expectations is extremely low. But I do want to express the positive side then, and I do believe in collaboration, and we don't know how many treaties or how many good diplomacy, how often it has happened in the history that good diplomacy and agreements have kept something bad happening. These things are left unknown to us. We only see when it fails, the diplomacy fails, or when the collaboration fails, and when nations are often joined by outer enemy, then we might. Let's say optimistically, idealistically, look into the future when we are joined in collaboration while facing the outer enemy in this environmental change and the need to address it. And I am freshly coming from the COP, maybe you were there as well, and what you get the feeling there is the sense of collaboration, and there is this power shift that you feel that there are more those who want a positive change and less those who don't want it or work against it. So maybe there is a balance somewhere that is tilting us in a positive way, and in this the scientific community has indeed extremely large and perhaps not so well filled obligation to obligation that in the future this needs to be more clear that in this collaboration and facing this environmental outer enemy we can only kind of go forward. So all the world's scientists join, or what was the unite? Yes, in that.
I mean, if I may, I mean, when I've been in number of COP meetings, and first ones when I went, then the worry was on kind of those side who said we need to go clean, we need to go green. How do we do it? How we get? I mean, to convince everybody that this is where private sector money needs to go. And then suddenly, a couple of years ago, you started to realize that it's shifting. Now, those who are worried are the oil-producing nations. They started to, I mean, put up programs that we need to maintain our share of global energy production, even if it will be different types of energy than oil and these kind of things. Then it was obvious that, I mean, the decision has been done and this will be sorted. So I'm not at all worried about green turn and stopping climate change if it can be stopped by not emitting greenhouse gases anymore. On the other hand, geopolitics cannot be delegated to the private sector. Democracies have to handle it, and there I think we are not kind of there. The risks are right now higher actually than they are in this kind of managing the green turn. And really I don't have a good answer, because I would not go that far and say that let's invite private sector in to resolve that problem too, because they cannot.
We have time for very last statements, and what I have picked from your broad spectrum from heavy pessimist to optimist is that there are some words. I just say that you spoke about urgency, that we can't wait. We spoke about the problem of possible collapse of systems which we have. We speak optimistically about collaboration, cooperation, and that's the way to go further. We spoke also about revision of existing systems, and a couple of times we mentioned also the sustainable development, not exactly the goals, but the ideas related to sustainable development. Within this picture of different notions, please, will you give to the scientific audience, I hope, a more optimistic view of how we can go further in the situation?
Well, we'll see. But there was one thing that you said you were going to bring up, the role of the indigenous peoples in the Arctic who live there. But I think I should end by mentioning them, because I'm not so sure that I can do it in an optimistic way. But still it's important to bring them up, because they are, of course, affected very much by this. And after the invasion of Ukraine, you know, the Arctic 7, they just on their own suspended cooperation with Russia without informing them even. So that created big problems. And this is not the first time that they are sidelined. They have this notion of permanent participants within the Arctic Council. They have a special kind of role, not on the level of sovereign states, but still. That, you know, with these big things, the Ilulissat conference in 2008, and then, you know, they were not part of it. So it's very important to bring them into decision-making for these people who live there. But we also have to think about, they're in a very uneven position. I mean, the Greenlanders are in a special kind of place in a way, because they have a right to secede if they, you know, and their arguments is not based so much on indigenous rights or decolonization or something. It's on self-government, you know, because they have this deal with Denmark, 2009 agreement there. Whereas, okay, the indigenous peoples in Canada, for example, they have territorial rights, not autonomous rights. So their position is not as strong, but still stronger than. And then we have the indigenous peoples in Russia who have very limited rights. So we have to make distinctions also about indigenous peoples, about their status when we are dealing with them, but also to give them some voice, stronger voice in decision making.
Thank you very much for bringing and reminding me about this. I noticed that we just don't have time for this very, very important question, but fortunately tomorrow we have special session about indigenous people. So,
yeah, but thinking about it, I mean, if we really want to stop this last empire in Europe, and I mean, make sure that it rather collapses quicker and with less damage than more, then actually it will also help indigenous people, because I mean, while Ukrainians are being killed in a hot war, then indigenous people in Russia have been kind of killed slowly as nations for decades and decades. So even if, and you said, let's see how the situation in Ukraine resolves, I have bad news from political side, then the ball is back in our hands, because resolving something in Ukraine, having either Ukraine even winning this war, will not resolve Russia problem. Russia problem can be only resolved if we keep the sanctions in place, keep the pressure there, be conditional in our relations with Russia for the decades to come, in order to make Russia finally, I mean, teach their school children everything which they did in Ukraine and other things like Germans did after the Second World War. Only then can we go back to normal relations with Russia, and only this way can we also help indigenous people within Russia.
At the moment, we have more polar researchers than ever, both in Antarctica and in the Arctic. And for the years to come, they definitely have a role to be very active, not just producing science published in peer-reviewed, high-quality journals. Of course, they should do that to get academic credit and so on, but to be active in the debate of the society, to take part writing chronicles and so on in the newspapers, to appear on television and so on with their findings. That is also very important, to disseminate the findings about the changes going on in the polar regions, both the ice melting, the ecosystem changes, and so on, which is so very special at the moment, but also for underpinning the green shift, which is so necessary if we are going to have a sustainable future. So the urgency, as you mentioned, is definitely there, and the role of scientists is really to be more active, both in the traditional academic terms, but also to take part in the debate in the society, to also influence and underpin the policy that the different nations are developing. Thank you.
Thank you.
Yeah, our experience in the Ministry of Foreign Affairs and in the linkages that we have with the scientific community is that, at least in our Antarctic Institute, is the level of the scientists participating in different programs is clearly increasing. So at least at the level of publishers, the people that are publishing has increased at least 40% regarding of considering what it was 10 years ago. So I think that the people has to follow that path continuously, research, and it clearly give us an important tool when we have to decide with the data, with the scientific evidence that they provide when we have to take political decisions in the different international organizations. So we need to keep in that track. The way that the our Antarctic Institute is doing with the different exchanges with the different Arctic and Antarctic researchers from different parts of the world is clearly increasing. So we need to keep in that track.
And I want to bring it very close to home. So we have a very tiny country who is where a Polar Club is celebrating its 40 years birthday, as I understand. So and with a very strong scientific background as well. And this is already a good seed to every future that we could have. So congratulations and thank you.
Thank you very much. And I just wanted to say that. Thank you for very big work you have done, but also we proved that the globe is round, because we started from Chile, where go around, and we actually ended with Chilean words. So, and thank you for your congratulations, and thank you very much, and for the audience as well. Thank you.